What's up? How's it going? Happy Sunday. Welcome to Large Data Bank. Welcome to Selfie Mode. Welcome to Large Data Bank. What's up, Sartak? How are you? I'm doing pretty good, I would say. It's a Father's Day. I had a nice long chat with my dad earlier. I don't often talk to my dad, but when I do, I try to make sure that we have a good conversation. It's very easy for me to get into a bad mood with my dad. I don't know if that happens with you guys, but if I don't make extra sure that I'm feeling positive, I might have a bad conversation. So that's why Father's Day, you really try to have a positive attitude, have a good conversation. We did. We had a nice, good conversation for about an hour. It felt pretty good. But yeah, so rest of the day, I don't know. I want to stream, do some programming. So that's what we're gonna do. So let me fill you in on what's going to happen. So last time, we were going really deep into the whole templating stuff, you know, trying to fix some irritating bugs with that. And like one kind of sad truth of the matter with this templating stuff is that like there's still this big mass of work that's laying in front of me for the templating stuff, which is even if I can figure out this like basic syntax and whatnot, there's all of these like little mini, you know, site specific things that we added to the code over time that have to be converted to the new method. So one thing that I started doing after the stream was like looking at some of the ones that I know that we can getting rid of them. And it got me back into this whole bounds checking fun stuff that I spent a lot of time looking at when I was writing this execution engine in the beginning. And if you're not familiar, so let me show you some stuff about what I'm talking about here. Let's say in Go, and this is going to be cool. This is going to be interactive. You're going to learn about Go, maybe. I'm going to learn a little bit more about Go, I hope. But essentially, Go is like a memory safe language, right? So actually, let me look at this other one that I was messing with. Go is a memory safe language, and what that means is that it'll never emit an instruction that is going to run past the end of a memory area that you've allocated. It just won't do it. It'll always emit a little instruction that says, if you're trying to access memory that doesn't exist, it's going to panic. So like throw a runtime exception and like tell the user essentially that like what you've done is bad. And so the thing is that those checks, those actually happen at runtime. It says essentially every time that you index into a slice, it'll check, you know, or rather, if it knows it has to check, if it can't prove that the index that you're looking up inside of a slice is in fact within the bounds of the slice, it's going to emit a little check that says, am I greater or less than the size of the slice? If I'm greater than, then I'm going to throw a panic. Otherwise, I'm going to continue on with my life. And those things, like, you know, if you're trying to write fast code, that those things are, you know, not great because, well, it's just extra work that the compiler has to do, or your program has to do, rather. It's a little bit meta. Like, the compiler makes extra work for your program unless you can convince it to do otherwise. And so it's kind of nifty. There's this tool in Go that lets you show off, or look at, rather, the results of this bounds check analyzer. And I wanted to show you that. There's kind of like a couple of different ways to run it, but ultimately what you do is you pass this flag into the compiler, this SSA/check BCE. BCE stands for bounds check elimination /debug equals 1. I'm doing this like funny thing with, you know, passing in some specific files just because this package that I'm compiling is kind of large, but you don't have to do it like this. You can also just run go build, and it'll be quicker. So if I run this, then it emits all this crap. And each of these lines here, it's telling me for a particular line of this source file, so const.eg.go line 389. Let's take a look at that line of code. Const.eg.go line 389. So actually, let's look at 390. So line 390, it says found is in bounds. What that means is that when I'm indexing into call is a slice, and when I'm indexing into call here with I, it cannot prove that I is less than the size of call. And so it has to emit a bounds check. And in this case, it actually makes a lot of sense because the way that we're getting I is this is actually a value in another slice. And this slice is made up of, this is like an int64 slice. And so this I, the compiler doesn't know anything about it. It could really be any value. And so it kind of makes sense that if you have any value that could dynamically be huge or small or whatever at runtime, you'd want to emit an instruction that makes sure that I is in fact within the bounds of call. It's not great for me because I know personally that cell is containing only values that are within the ranges of this particular call, but the compiler doesn't know that, and I can't really convince it otherwise because you just don't have a method of doing that in Go since it is this memory safe language. So I think, I mean, for example, I could like hack around this by using some sort of unsafe thing. And that might be kind of cool, but that's not really what I want to talk about. What I want to talk about is like some simpler cases where we're not doing this and we could be. That's kind of like the crux of it. Because check this out. This is a very interesting situation. And let me make the font size a little bit bigger because I feel like it's slightly too small. I'll go up to 26. Bam. Okay, so check this out. You see, I have a call, which is a slice, and I slice into it, and I say, Mr. Compiler, give me values 0 through n of this call. That's what this 0 through n slice syntax means. It means just give me a window into call from 0 to n. And you know, this is gonna have a bounds check on it as well, and we can show that. So if I jump back to my little analysis area, you can see that for line 393, I have this thing found is slice in bounds, and what that means is that it's going to run a check. You know, does call have 0 through n slots? If call only had 0 through n minus 2 slots, this would panic. And the left side is 0, so it doesn't matter. But if this was like 3 or something like that, it might panic for another reason. But the point is like, okay, so it does this check. And then check this out. Here we have a loop. And we're looping over all of the values from 0 to n, just like we said, right? Check it out. We said, give me the values from 0 to n. And I'm going to loop over the values from 0 to n. And I'm going to look up for each of those values into call. And I'm going to set it. I'm not looking up. I'm setting that value to the c.console thing. However, faithful viewer, what is the deal with this? I just said that the compiler will say is in bounds if in fact it has to emit a bounds check. And why does it have to emit a bounds check here? Because we can see, you know, I can see that it's illogical that you would have to check. We know that I is between 0 through n, and we know that we've just constrained call to be from 0 through n. So this is why I've titled this stream, Large Data Bank Tries to Fight with the Golang Bounds Check Analyzer, because realistically this makes absolutely no sense why the analyzer couldn't prove that I is always within bounds. If you know the answer to this, let me know, because I don't get it. I know how to fix this, and I don't know if you're ready for it because it's really goofy, but I can fix this by saying, I can make an empty declaration like this, underscore equals call of n minus 1. So this is saying, give me the value at index n minus 1 of call, so the very last value in call, and assign it to nothing. Now, if I go and recompile this file, it's going to give me a bounds check here and no bounds checks here. Why? I have no clue why it cannot prove it based on this, but it will in fact do that. So check this out. If I run again, go tool compile, and then look for line 396 now. Oh wait, I do see something. Okay, so it's still a mystery. It's still a mystery. It's confusing because in a situation very, very recently, I did this exact same thing, and I did convince it not to do a bounds check. So why is this one different? I think the situation that I was looking at different was the opposite. Instead of setting call I to something, I was getting call I and putting it somewhere else. But like, why? 396. Why do I have to check as the compiler? It really makes no sense. There is a cool tool I wanted to show off too. So if I pipe this to a file, analysis.out. James Harris, what's out? That What's up? I mean, that font is smooth as hell. Thank you. Which font? I've got two on screen. I've got this guy. This is Source Code Pro in the editor. And this one over here is like, I don't know. Menlo. It's just like the default Mac one, I guess. Which one do you like better? Do you like Menlo better or do you like Source Code Pro better? So if I run this view annotated file thing, this is actually super neat. When I go to my web browser over here, this is actually going to put the results of this analysis alongside the text of the source code. So that's pretty cool. And you can see that, wait, this isn't the one that I modified. I was on 395. So line 395, It sort of seems like, the line numbers are off, huh? Because it's saying find is bounds on line 395, which does not have any bounds checks. Okay, so something is going slightly wrong. Oh, analysis.log. I wrote it to analysis.out. Let me fix that, run it again. Okay, we run again. We go down to line 395. So now we can see again that this line has a bounds check, which I expect. But why does, let's make it bigger. Why does this line have a bounds check, you guys? Why? Why? I've told the compiler. I've told it. I've said, we know that call has at least n slots using this and using this, but this one doesn't work for some reason. Why then can it not infer it for this? Is it because it's inside of this weird closure? Could that be the reason? Could that be the reason? That would be really sad, huh? You know, it's possible that it's because of this closure business, and that's making me a little bit suspicious because we use these closures all over the place. So just for the purposes of argument, let's say we edit this to just, I mean, this doesn't make any sense, but I'll just put this code right again up above. Get rid of this thing, run gotool compile again, run my little view annotated file. No, it's the same problem. So okay, but what if I include that thing that I think will convince the bounds check analyzer otherwise? Do we still have the same problem then? It looks like we still have the same problem. What is the deal with this? I don't really understand. Okay, so there is this other thing that I wanted to check out. There's like this advanced SSA checker thing. How do you get to that again? Golang SSA output HTML or something? Go SSA func equals main, go build. I think it's like this, right? How do I get that from gotool compile? Is there a way? Print assembly listing. Disable bounds checking. That's kind of what I want. Just turn off all the bounds checking. No, I can't do that. I need some of the bounds checking, just not all of it. How do I get it to output this nice HTML thing using, so go SSA func for gotool compile. Is that something that we can do? Oh, I see. You can use it even for go. Okay, so check this out. This is gonna be cool. I've never done this. So go SSA func equals. Now what is the argument to this thing? Oh my God. Do you guys, I hate Medium. What happened to Medium? Medium now blocks me from reading articles. Does this happen to you? It's like completely heinous. I bet a lot of people put their stuff on Medium and then it just, you can't really use it anymore. Rockheal.org. I really like Rockheal's, she is a great writer. And she knows, okay, so I think you just literally say go SSA func equals main. Let's try that out. So if I say go SSA func equals main, and then pass this whole thing. What do I get? main. That's not what I want. Did I get an HTML file? Doesn't really look like I got an ssa.html. No. Oh my god, I want this Medium article and I can't read it because of this ridiculous ad blocker. I mean, whatever you want to call this thing. Oh my god, you've read your free stories this month. What if I open it in an incognito window? Is it gonna complain about me still? No, it doesn't. It lets me view the article if I look at it in an incognito window. So that's great. Okay, so go SSA func. So how come it doesn't work then, huh? Maybe I have to turn off this debug flag and then it'll do it. No, it doesn't seem to do it. That's annoying. How do I get this SSA func thing to print? What if I just did, okay, what if I just did go SSA func equals main? Is that how I spell it? Go SSA func equals main. Go build package SQL call exec. This is gonna be a longer compile time, but, oh, there we go. Okay, so it worked that time. Kind of weird. I guess maybe it doesn't really work with the go tool compile invocation. I don't know what it's doing now, but it seems to have finished dumping. So I can just stop now and maybe open this up. Put it up here on screen. Okay, so this is cool, right? This is like a whole bunch of stuff that I don't understand, but can I look at a particular function in this? Is that something I can do? This doesn't seem to really have that sources. This seems to have just like one random function in it, which is not really what I want. Maybe I have to let the whole thing run. I'm gonna try it one more time. Maybe this is something that I should do on my little worker node because this uses a lot of CPU. It's really slow, whatever this thing is doing. I'm gonna run it. Okay, I have this other machine going that I can tell it to do stuff while I'm talking. So I think I'm gonna do that. So I'm gonna run the same thing over on this machine. Spell that right. Open SSA.html permission denied. Huh. I wonder if this thing sort of rotted or changed. It kind of seems like maybe it works differently now. Go SSA func, go build. Maybe it works. Yeah, so this is exactly the issue I was looking at. Oh, maybe you actually do have to pass in an actual function name. Is that the issue? Go SSA func. Maybe what it really wants me to do. Let me try that one more time. So if I run this guy, and then instead of passing main, I pass in the name of the function that I want to analyze. Perhaps that's what I want to be doing here. And in this case, the name of the function I was trying to analyze was this. I see. Well, this is troublesome because how do I say I don't know. What if I just said next or something like that? Would that work? Doesn't seem to. Const int64 op.next. What about this? Hey, that worked. Okay, finally. Okay, cool. So if I open this up then. Yes. Okay, this is looking good. This is looking quite promising. So check this out. This is actually really quite sick. So here is the code that we were looking at earlier in our IDE. Let me close this guy out. And you can see that it's going to give me several representations of the Go code in these different windows, I guess. So this is after parsing. It kind of looks like this. And then I guess there's all these different phases. I don't know if you can squint to read these, but you've got start, number of lines, early fee elimination, early copy elimination, early dead code, short circuit, decompose args, all of these different optimization phases that the Go compiler does. Zero arg case, op dead code, like so much stuff, right? The question is, can I possibly use this to figure anything out, or is it just going to be way too complicated? What I want to look at is like, is there a phase for bounds check elimination? It's funny, I have to tilt my head like this. Lower, right barrier, branch elimination, check BCE. How about this? Unfortunately, this looks fairly incomprehensible, but what's really cool is that if I highlight something, does it like propagate through everywhere or not really? So if I highlight this line here that says call I is equal to const val, this is the thing that is getting bounds checked that I don't think it should be. Okay, so it highlights it orange here, and then in the next pane it highlights it orange. Does it highlight it orange in the following pane though, or does it sort of lose the thread after that? Oh, it does. This is awesome. This is actually super cool. It's kind of over my head, but it's really cool. So if I search for orange way down in the phase called check BCE, what do I get? I have an is in bounds check, but it doesn't help me figure out why there's an is in bounds check here at all. I'm sort of left on my own to figure that out. I wonder, how do I deal with that? So if I go to the one right after, actually, here's a question. For something that does get bounds check eliminated, what does it look like in this SSA func thing? So if I go back to my other window, which was this, so what does one look like that did get bounds check eliminated? Like nothing in this file got bounds check eliminated. So I guess I have to look at another example. That's fine. I have one queued up, which was this cast.eg.go thing. And I want to run it with, where I redirect to analysis.log, and I want to change it, instead of const.eg.go, I want to compile cast.eg.go. And then I want to run my view annotated file thing, go over here. If I refresh and then go to cast.eg.go, here is an example of something that gets bounds check eliminated. We're doing a loop over from I to n. We're looking at input call of I. And for some reason, we know for sure that no matter what I is in the range of 0 through n, we don't have to check its bounds. We know that input call is in fact big enough for that. So the reason that that happened is that up here, we wrote this code here, underscore equals input call of n minus 1. So that's supposed to teach it that, hey, n is in fact still smaller than the size of the column or the slice. So if I do this, so then I guess what I want to do is run this go SSA func thing on the cast function and see what it looks like in a sense. So this is going to be, this is just called cast. So go SSA func equals cast, go tool compile, like so. And then I think I'll get an SSA func.html, hopefully. This one's a bit slower, maybe because the file's so large. I'm drinking a Fat Tire, by the way. Anyone a beer fan? Anyone like Fat Tire? I think it's a good beer. So if I open up this guy, and I really want to open it up in this window. Can I convince it to do that? There we go. Wow. Okay, so this HTML file is actually so large that it's taking a long time for the browser to even load it, which I find kind of hilarious. Maybe this SSA.html thing is not really well suited for this kind of analysis that I'm doing, because it's just too much output. Could that be true? And it's sad because the the phase that I really want to look at is like 16 phases deep, you know? But it does, when you open it like this, it does actually expand all the phases, which is kind of cool. So we can think about them. There's the start phase. Don't know what that might mean. Number lines. Do we number the lines at that point? I don't know what that is. Fee elimination. Does anybody remember their compilers courses and remember what a fee node is? Copy elimination. Dead code elimination. That one's pretty straightforward. Short circuit. Maybe that's for like, I don't know, if conditions that are static or something. Decompose arguments. No idea. No idea, no idea. Zero arg case, no idea. Dead code. Maybe that's for static conditional branches, kind of like the thing that we did in execgen, removing things that are statically known to be false, like if false, then something. We can just delete those. Unfortunately, it's taking quite a long time. I wonder, like, is it just, like, how big is this HTML file? It's 166 megabytes. So this HTML file is just really, really big, and that's why it's taking so long to load. Wow. Cool, though. I mean, there's a lot of information here if you want to learn about it, I guess. It's just kind of hard to parse if you're a human being. It's kind of unfortunate. It kind of seems like my browser hung, too, trying to load this giant file. All right, I think I'm gonna put the kibosh on it. It's not really working for us. Okay, all right. So I guess that's then going to have to, what we're gonna have to do is just continue poking at this damn thing until we can figure out how to, wait. So the const one is the one that was messed up. It's good because this one's actually it's a lot simpler than the cast one. But it's just confusing to me why even this very simple case doesn't seem to allow us to eliminate the bounds checks, right? So what is wrong with this? What is wrong with this? Maybe if I said, this is dumb, but what if I put this assignment up here? No way that's gonna change anything, right? View annotated file, go to browser, refresh, go to const.eg.go, and then what line did we edit? We edited line 391. Yeah, so same problem. Same problem. I really can't explain this, actually. I cannot explain this. It's really perplexing, you know, because let me show you something. If I go to Godbolt and I put in the very same thing, so I'm gonna make a function that takes in a slice of int64. I mean, I was doing this earlier. It takes in a slice of int64, and it takes in an n, because we can't necessarily prove that n is the same as length of call yet. And it just loops over c, right? And it sets c to some value. Maybe it takes in a third parameter like this. C int equal, or I guess this is gonna have to be v int 64. It doesn't return anything. Okay, so this has to do bounds checks, right? Because in this case, n is just some arbitrary value. And the compiler cannot prove at this point that the length of C is less than n, right? So how do we check to see if it does bounds checks? Well, we go to the assembly here and we sort of use our eyes and find out that for this line here, C of I is equal to V, it's not just setting something, it's doing something more complicated than that. It does a comparison. Depending on the result of that comparison, it jumps to PC38, which is back to the top of the loop. Otherwise, it jumps to this other part, PC67. This is this panic index thing that I was trying to explain earlier. And this is saying that it was not able to eliminate the bounce check. This is the bounce check. Check something, panic if it doesn't work, right? So I can eliminate this bounce check very easily in this function by saying underscore is equal to C of n minus 1. Telling the compiler that it's gonna check the bounds for n right at the top of the function. And then forevermore, it doesn't have to do anything fancy. You can see that in the actual loop here, which is now at kind of PC51 and PC58, that it's just jumping between 51 and 58. And it never has to go to PC73, which is the panic index. That's only for this first early bounce check thing. So this is how to do bounce check elimination in a simple function. The question that I have is in our function over here, which is, you know, I mean, it's like really quite simple in itself. Why does it not get eliminated in this case, right? It's literally the same. I mean, if I were to put this here, this is exactly the same code as that we wrote in Godbolt. Exactly the same code. This is a little different, but it doesn't really matter. I mean, I could make it the same by saying v is equal to c.constval, and then say call of I equals v. And then if I recompile that, I'm expecting that I'll still see that it's doing a bounce check for a reason that I do not understand in the slightest. Just check, so that's line 386, right? So why? Why? It's the same code as this. It's the same code as this. Okay, let's go a little crazy. What if we made a function that is literally this function and then call this function from our code? Would that get rid of the bounce check, or are we in some kind of like spooky crazy world due to the size of this file or something like that? You know, like what could it be? Func foo. So we're just gonna, I mean, let's just copy this, right? It's the same function. And we'll just call foo right here. We'll say foo, so we're passing in call, we're passing in n, and we're passing in c.constval. This is exactly the function that we wrote in our Godbolt. And let's see what happens when we compile it with go to compile. Will we see the bounce checks, yes or no? Yes or no? Foo. Foo has no bounce checks, okay? What is up with that? I'm actually shocked because it's telling me that if I manually inline foo, the bounce checks return, but if I don't, then there are no bounce checks. That seems like kind of like a compiler bug, TBH, right? Like, I can't really rationalize why else this would be happening besides there's some issue with the Go compiler not really getting something. I don't know. I don't get it. Hey, thanks for the follows, No Bodad and JB Pratt. I'm not sure why my Streamlabs isn't working. That's a little bit mysterious. Why isn't my Streamlabs working? Who can explain that? I don't know. Maybe it's down or something. But anyway, thanks for the follow, you guys. Hope you're doing well. Yeah. Okay. Well, hey, we're really close to 200 followers, by the way. So if you are watching, and you feel like giving me a follow, we're at 197 followers. Hitting 200 would be pretty sick. Anyway, okay, so let's try to figure this out, shall we? Like, we've got this code gets its bounce checks eliminated. Now let's just for the purpose of argument, let's grab this whole thing, put it round down here, replace C with call. That's the same thing. We've manually inlined foo. We've gotten rid of foo. And then if we run go tool compile, we run view, what we see, 325. Whoops. Foo, do I still have that? What we see, whoop, undefined v. Okay, I made a typo. Hold on. It's not v, it's c.const val. Const val. Could it somehow have to do with the fact that, like, no, man, I don't get this. I don't get it. I don't get it. Is there something special about, like if it sees a closure? Okay. What if, okay, this is crazy. This is crazy, but what if we just got rid of this? If we got rid of that function, we run it again, will we see the bounce checks this time? Did that work? Hold on. Will we see the bounce checks this time? Oh my God. Okay, so I think I know what the issue is. And it seems to be that the Go compiler has a hard time doing bounce check elimination if it sees a closure in the same function body. Like, if I remove this, I should really capture this and write an issue for them, because I don't understand why this would make any sense. But it appears that because later in the code I have this call to this thing that takes a closure, earlier in the code I can't eliminate the bounds checks. And that's actually extra bad because we don't actually, this code, this was just here for the purposes of demonstration. In the production code, we actually have to call this perform operation thing for some reason. I don't know what this does. It executes operation and updates the memory account. Oh, I see. So it gets the memory footprint and it changes. Oh, I see. So if why does it have to do this? Why does it have to do this? It's saying that if I started to use more memory after this operation, it wants to pay attention to how much memory I'm using. But what I don't quite get is how could this possibly change the amount of memory that we're using, right? Get vex memory footprint. What does this do? Estimate batch size bytes. This doesn't make any sense why we would have to call this on. Because it doesn't actually check the, it doesn't actually look inside of the vectors. It's literally just for every type making up some estimate. So why do we have this perform operation here, huh? What? Who did this? Was it me? No. Refactor allocator to huh. It's sort of ancient history. It's like before this commit. Well, I don't think this makes any sense. I mean, I'm going to delete this and then I'll see if somebody yells at me for it, because I just don't think it makes any sense. But I've learned a lesson, which is a very sad lesson, which is that, like, this bounce check eliminator has issue with closures. You know, what if we Googled that? Do you think there's a bug open? So bounce check elimination Golang closure. No way to hint to eliminate bounds checks in... No, wrong. Odd bounds check elimination. Ah, this seems relevant, maybe. Go 111 can eliminate the 2 bound check enclosure in all 4. But I'm using Go 114, so this doesn't really make any sense. I don't know, maybe I'll open an issue for this later. But anyway, I think that I can get rid of this stuff here. So I'm gonna do it. it'll look like this. Much simpler code. And then hopefully, if I were to remake my const file thing, which we have to compile because it's in fact a piece of code that gets generated by this other thing that I mostly work on stream, which is execgen. Then anyway, I have to sort of remake that using this other tool, but in any case. So then I can what happened? Can't find import. I have to run go imports on it as well. Const. Then if I run this, then if I run this, then I go back to my analyzer thing, then hopefully I will see no bounds checks. So here's, okay, we're back to having bounds checks, but now it's like back to normalcy because I know this one, for whatever reason, doesn't get rid of things, but I can in fact get rid of it using a very simple technique known as saying execgen dot unsafe get call comma and -1. So what this does, I mean, I really don't understand why this doesn't do it. This is something else that I'm quite confused about actually. But if I do this, then the bounds checks will go away. And this one we can't eliminate, right? Because this one it's dynamic. We're looking up into call a value I, which is a value from cell. It's not an index that we know what it could be. So this could be any int64. Can't look this thing up. It's got to have a bounds check. It makes sense. It's sad, but it makes sense. So this one though we can get rid of. So let's try this again. So we're gonna remake not cast const.eg.go. We remake that little fella. We go imports it. We go tool compile it. What's the matter with you? Cannot use call as type int. What did I do? Not call equals, underscore equals. We just want to fetch it. We don't want to store it anywhere. Okay, do the whole thing again. I should really make a little makefile target for this because it's a lot of repeated stuff, to be honest. So go imports, go tool compile, then view annotated file. This is a cool tool, by the way. I just learned about it today from the Gophers Slack. I don't know if, are you guys, if you're Go people and you want to have a good community to hang out in and ask your questions about Golang to, you should 100% join the Gophers Slack. It's open to anybody and they're really smart, but they told me about this tool called view annotated file, which prints kind of this nice, overlay of the source code and the output of this, SSA func checker thing. I'll show you what it's called. Oh man, I got too many browser windows. View annotated file. So Louvre, if you're out there, Louvre, I appreciate you. This is a great little program. You should download it, play around with it if you do this kind of thing. It's really useful. Okay, but anyway, the point is that, check it out, we did it. We put this early bounds check here, saying that give me the n-1th thing from call, so that'll panic if it doesn't have a long enough thing. And then the loop afterwards, it doesn't panic, it doesn't have to do a is in bounds check, which is faster. Now, here's the exciting thing. Here's the exciting thing. We're going to demonstrate that it's actually faster by running a benchmark. I was hoping to do this on stream because I think it's really satisfying. So here's what we're gonna do. We don't want to do benchmarks on this computer because it is a streaming computer and it's busy doing all sorts of stuff. So we're gonna make a commit for this. We'll say it, call exec, remove bounds checks from const op, release node none. So we're gonna push this to this branch. And then I'm gonna jump over to this other computer that I have open, which is like a cloud computer. It's got a bunch of CPUs and stuff. I don't know. The whole point is that it's just a computer that isn't doing all sorts of desktop crap. I'm gonna fetch from my branch. Gonna get branch, get reset hard, mine, delete branch. Whoops. Yeah, delete range. That's the name of my branch for some reason. There's a good reason for it, but I'm not gonna go into it. So here's what I'm gonna do. I'm gonna run, I have this program called script bench, which is pretty neat. And what it does is it actually will run a benchmark on 2 different branches and show me, 10 times each or something like that, and show me the differences. And it's gonna do a little bit of statistical analysis to throw out outliers and stuff like that. It's kind of neat. So first I have to find a benchmark that I'm gonna run, and hopefully I can find a benchmark that is testing exactly this const thing. Do I have that? I might actually not in this case, because who's gonna benchmark a const op? That's kind of sad. Maybe I'll write one real quick. Should I write a little benchmark for this real quick to make sure? Maybe I'll just continue on, because the thing that I have to do on this stream is there's a bunch of things that are just like this that I have to edit all at once. So I'm gonna skip this one because I know there's gonna be benchmarks for one later on. So we'll move on to the next one that needs a bounds check fix. So the way that we're gonna check for this is we're just gonna look at this other commit that I made, look at the changes that I made, and try to edit them. So distinct, I think I did a commit for distinct already, didn't I? Yeah, I did. So it's not that one. I did cast, I did const, I did distinct. What's the one after this? Data manipulant gen, that's something unrelated. Min-max ag. How about proj const ops temple? Looks like we already do the same the technique here, so I can skip that one. What if we already do the technique in all of these places? This one does not do the technique. So we can check this one out. Select in template. So let's look at what this code does. Select in. What this operator does is it's the thing that in SQL, if you say, select a value in and then a tuple of values, it's the thing that searches through the tuple trying to find whether or not the thing that you're looking through, the dynamic value, is part of that tuple. And here's kind of the template code for it. And what it looks like in the generated code is this. And let's look at a good example here. We'll look at the int64 one, because that's just my favorite, simplest example. So here's the core loop. It says for I is equal to 0, I less than n, give me the I thing in call. Now I'm guessing that because of whatever bug that I don't understand is preventing this thing from doing its bounds check elimination, I'm guessing that this thing does not get its bounds checks eliminated. Let us find out using that go tool compile technique. We're going to run go tool compile, and then instead of passing in this const.eg.go file, we'll pass in select in.eg.go. Okay, it didn't like it. Maybe it has some other, let's see, get datum to physical function. One kind of goofy thing about the way that I'm doing things is that I've got to explicitly pass in all the files that are referenced in this file, just due to the fact that I'm not using go build directly. It's a little bit annoying, but package SQL call exec. The reason that I do it this way though is that like this package is really ginormous, and if I were to just run go build on it, it would just take forever. And all I really needed to do is compile these 3 files, so it's quite quick if I just do that. So I'm gonna pipe this to analysis.log, and then I'm gonna run my view annotated file program on it. Go back over here, and now I get to look at this new file. So last time we were looking at the const.eg.go, and now we can look at select in eg.go. And we wanna go down to that line that I was talking about before, which was line 1695. 1695. So as I suspected, we are doing a bounds check when we look up into call for no reason, no apparent reason. Here's actually, I'm quite curious, if I do this simplified example in Godbolt, so not using the underscore equals thing, but just using this slice syntax, do I get the same sort of issue? So what that would be, I don't need any of this stuff. What that would be is saying, instead of saying underscore equals c n minus 1, I would say c is equal to c o to n. I guess I could just say 2n, but see, in this case, it really, there's something going on, because it, in a very, very simplified example, I do get the bounds check eliminated. You can see that this line does a panic slice if it needs to, if n is too big for c. But then down here in the loop, it doesn't have to, meaning the bounds checks got eliminated. But in my example, which is for all intents and purposes the same kind of thing, Doesn't get eliminated. I don't get that. This is maybe I just have to file a couple bugs for these people. Maybe that would make things easier. But in any case, I think all I have to do to work around this is to say underscore is equal to execgen dot unsafe get call and -1. And I think I want to do this outside of this big if conditional thing because we do it a couple times inside, and this will just wipe them all out in one fell swoop. So if I do that, and then I run make package SQL call exec select in.eg.go, that's gonna recompile the code generator. That was fast. Recompile the code generator. I have to run go imports because my make file target's up. I have to run it on select in as well. And then if I run go tool compile, and Silicky, what's up? I'm drinking a fat tire. You know this beer? It's pretty good. I'm into it. And then if I run my view guy again, yeah, hell yeah, it is a good beer, right? Then I think at this point, hopefully, our little bounds checks will have gone the way of the wind. Let's see, what line was I at? I guess I can just search over here for underscore is equal to call, and then so it doesn't get rid of the bounce check here. Maybe that's because I reassigned call. I mean, again, all this stuff is just no op. It's really so goofy, so goofy. Are you familiar with this stuff, Ansel? I don't know if you've been listening to my rants so far today, but like, I'm dealing with the way that the Go compiler elides these bounds checks. I don't know if they do that in other languages, but it's really quite frustrating because it's very inconsistent and it's hard to predict whether it's going to do these elisions or not. So I run this again, run this again. It's like, it has some like little, you know, I don't know, a little mini analyzer. Martin Janashek, thank you for the follow. Dark side, yeah, exactly. The opinionation. I need to run go tool compile. The dark side. Yeah. So did it work this time? That's one with bytes, which we can't really do it to. Here's int 16, which we can do it to. So we, oh, it's still out of order, so it's probably still gonna have the problem. Ay. Zero compiler hints as a feature, what a feature, yeah. I agree. Okay, so if I reorder this, I think it's just when you're trying to do this, hey, last one, ow, thank you for the follow. I don't know why my follower alerts aren't working, you guys. I'm sorry about that. They're usually kind of fun. I wonder what the deal is with that. Is that something that you're supposed to like check before you stream or something? Just, it seems like it usually works, so I don't know why this time around it wouldn't. It seems like it would be pretty annoying to have to check that every time. Underscore equals call. No? Oh. Okay, so here's our example again. This time we've got them in the right order. We reslice call, we grab the last element of call. Oh yeah, and then down here, isn't that goofy? It's just these little tweaks, and then all of a sudden this one gets its bounds checks eliminated, which is the dream. So we did it. One small little change. one small little bounce check is eliminated. And I believe that even just this itself will have a measurable impact on the benchmarks. So let's find out. Let's find out if that actually did something. So we're gonna make a commit for this. Call exec, eliminate bounds checks for select in. We'll push this. We'll go over to my benchmark computer here. We'll fetch, we'll rebase. And now we can run, I wanted to show off this like little automatic benchmark comparator thing. So I wanna show that off now. So first let's figure out the name of this benchmark that we're gonna do. So this is select in. There's definitely a benchmark for select in, right? Select in. So I have something called benchmark select in int64. So if I run it, let's just run it by itself first. So make bench package equals, well, do I want to, yeah, I'll do this. Package equals package SQL call exec, benches equals, hey, Amir Attack 88, thank you for the follow. Benchmark select in int64. Okay, so hopefully this is going to recompile a bunch of stuff and run a benchmark. We can see its output. And once I make sure that we're really running the right benchmark here, I'm going to make it compare between these two branches. And hopefully we'll see a performance impact just from that little bounce check elimination, which by the way, it's just so funny because you can't tell unless you really do this careful analysis whether or not you're gonna get these bounce checks or not. So it just goes to show that I think that you have to spend a lot of effort when you're writing performance sensitive code, looking at like compiler debug output in Go, which is, I don't know, it's sad, I think. A little sad. Maybe it's not that sad. Maybe it's just like most of the time you're not writing code that is this sensitive. So I guess we're running a few different checks. They all have, so I guess the checks here are whether or not we're using a selection vector, whether or not we're having nulls. That's 4 different options. Now if I run, let's see. So if I go like this, if I grab these two things and use them as environment variables and then run script bench, then I pass in a branch, which is my old branch. So I'll pass in, let's see. I guess I can pass in this just SHA, I suppose, just so it doesn't have to compile that much. This, and then the new branch is delete range. This is kind of a neat thing. It's gonna automatically check out the old branch, run make bench. It's gonna pass in count 10, so it'll do a little bit of, you know, noise reduction on the benchmarks. And it's gonna do that on both of the branches and give me the results. So we'll let that go and go do something else in the meantime. I think I do have another question, which is whether we can get rid of any of these other bounds checks. Some of the ones that we can't really get rid of because they're too dynamic. Like this one, for example. We already talked about this, but cell is a vector that has any int64 in them, and you can't really eliminate a bounds check when it's any old int64, even though I happen to know that those int64s won't be greater than the length of call. We can't really convince the compiler to do better here without using unsafe, which we don't really want to do. This one, cell IDX. What is IDX here? IDX is an integer, and I guess we increment it arbitrarily from time to time. So that's also one that we can't really get rid of because from the perspective of the compiler, we have no clue whether or not IDX is going to be greater than the length of cell. So we have to leave that one alone as well. I think this one, let's see, let's make our window a bit bigger here. I think this bounds check here is actually getting caused by the inlined body of nulls.nulladd. Nulls.nulladd is a thing, it's checking a bit map thing. It's like we have a couple of bytes that we were using as a bit mask or a bit field. I don't know what you want to call it. Just a big, where the ith bit is whether or not the ith row in a vector is null or not. What's the rationale for avoiding package unsafe? I don't know. It's just not something we've done yet. We could, I mean, I think it's just opening a can of worms. It's not something that I would say no to completely. It's just like, I don't know. It is nice to have panics and not memory corruption if you've written bad code. That's basically the rationale, right? If we had an error, then instead of, corrupting somebody's data, you would just crash your node, which is probably preferable. I think in this case, I mean, this little core algorithm is very tight. We're pretty careful about the way it works, so it might be fine. but I don't really want to do it, so I won't. The other funny thing is that these loops are never really the bottleneck in our database. It's never really these execution engine loops. I like to make these really fast because it's satisfying. Okay, so here's the benchmark results. And okay, so this is shocking, you guys. The shocking conclusion seems to be that in most of the cases, the code that I've written is slower than the old code. So the way that you could read this is that for every line, we have a benchmark, which has, you know, the name of the main benchmark and then these Booleans, whether or not to use a selection vector, whether or not there's nulls in the input. And it's got the old time per op, which is how fast each operation was on this old branch, this SHA before I made my commit. And how many microseconds it took to run the operation after I made my commit. And as you can see, for whatever reason, 10% slower, huh? Now that is perplexing too, because, well, I eliminated this whole bounce check. So why in the world would it have gotten slower? That is my question. So let's actually, why don't we can go back and look at the generated code again, you know? Is this still the select in? It is, right? So for this last case, which is the simplest, I always like to look at the simplest case, which is when there's no nulls and no selection vector. That's this last case, and it got slower by about 10%. Just making sure that, yeah, this is in fact the correct order. So, and let's just eliminate bounce checks for select in. Here's what we did. We added a slice. We removed these slices. So perhaps removing these slices is doing something that I'm not understanding. But anyway, the code for this is this last case where there is no selection vector, and this else says, you know, there's no nulls. And run set selection. This has no bounce check. So it's sort of like, you know, like what could possibly have made this slower, right? What does comp in 64 do? So what this is doing is for each value inside of filter row, which is a slice of in64s, it's comparing the single target LM to each of the values in the filter row. And if it ever finds a comparison, then it leaves, returns true. If it had nulls, it returns SI null. SI null, what is that? SI null? Oh, it's like a constant. Okay. Oh, I see. And then otherwise it, let's see, go back. Guess we can look at it in the actual editor. Comp in 64. Otherwise it returns false. I mean, this is just like perplexing. Cypher, what's up? It's going good. It's going good. How are you doing? Happy Sunday. Happy Father's Day. Yo, were you always a partner? You have the verified check mark. Is that new? That's pretty dope, though. It is new? Congrats. Dude, that's awesome. That's so cool. That's big news. Oh, it's not new. Oh, you've been partners since 2013. Okay, cool. Cool. Well, old congrats. I think there's a little bit of lag in the stream, so I'm saying things that you already explained. That's very neat. Are you gonna stream another Crypt of the Necrodancer thing soon? That was fun. I liked watching that. So basically, cool. Basically what we're doing is we've made a tiny change to our code to try to eliminate some bounds checks. We're trying to figure out why doing that actually made the code slower. That's what we're up to today. You're fickle when it comes to actually streaming. That's funny. That's fair. That's fair. Okay, that's cool. That's very cool. That makes sense to me. Fickle, what a word. So I guess the only other change that we did was remove this. So I guess my next question would be, why did removing that possibly slow anything down further? So I guess what it would be is right here we would have, and what we can actually do is we can just edit this code on our benchmark box to try to see whether, what small change we could make that would make everything faster or slower. So let's do that. Curious about my keyboard. I actually have a keyboard command for that, but what advantage do I think it has over traditional keyboards? What was the process of switching like? Well, the reason that I started doing this in the first place was that my wrist started to hurt when I was using like the normal kind of straight ahead up and down keyboard thing. So I switched to this Microsoft ergonomic thing, this like big boxy black one that is it's got some tilt, it's got some curvature, but the most important thing is that it puts your hands kind of at an angle like this. Like you see how my arm is I don't know if you can see this. My arm is sort of straight up and down when I'm using a keyboard. Whereas if you're using like a MacBook keyboard, you have to like tweak it like this. So there's not a straight line between your arm and the hand. And that's important because when you have sort of these straight lines, then you just don't like mess up your hands. And I like having the split thing because you can change the angle. Plus it looks cool. I mean, I'm not gonna lie. I like this thing because it looks really awesome. I got it from some people on Reddit. I like mix and match some parts. I don't know. It's a whole like world of wasting money if you want to get into that world of wasting money. But I think it's kind of a fun hobby too. So the other thing that I wanted to actually do is when we run this benchmark, we can pass in a flag called, let's see, test flags equals CPU profile equals maybe foo.out. So what this is going to do is it's going to run the benchmarks again, but it's going to dump some profiling information to a file, and then I can inspect that profiling information using a program called pprof. And I'm going to do that to try to figure out where the time is going in a sense. I think I already know in this case, but it's kind of good to know. Oh, and I also want to constrain the benchmark that I'm running to just be the simplest case. So use cell equals false, comma, has nulls equals false. I think if I do this, then I'm just gonna have a little bit simpler of a, I don't know, domain to look at, which is always good. So if I run this again, then it's going to, okay, so check this out. So if I run pprof on foo.out, this is a really cool program. If you haven't used pprof, I recommend it. If you're used to profilers, I don't know. This is a nice profiler. I took some time to get used to it because it's kind of text-based, but I like it a lot. So I type top in pprof. Let's make my window a bit bigger. If I type top in pprof, but it's cut off for you guys. That's a little bit annoying. I'll just make it this big. It does not interface with Linux perf. No, the way it works is, I think the way it works is literally like the Go runtime will just collect stack traces constantly and try to sample how many times it sees the program at a particular set of stacks. Is there a Go package for Linux specific perf? I don't actually know. Similar to perf top, yeah. Keyboard model. I don't know if you missed this, but I'll just do it again. I like that. Talatary, what's up? Hey, thanks for the follow, by the way, Talatary. All right, so if I type top, it's gonna tell me the top most, the biggest user of CPU was this function here, select in top, and it was using 0.63 seconds of flat CPU time. which makes sense. That's the function that we're kind of messing with. So if I type list next, it's going to give me a listing of the code that was spending all that time. So here's the code, and you can see that it's spending 80 milliseconds doing this, loop incrementing. It's spending just 10 milliseconds doing, I mean, maybe this is the issue. It's like this, it's kind of like, well, I was gonna say maybe it's that like gets lost in the noise. The thing that I bounds check eliminated is just so little time compared to this more meaty function. It doesn't really matter. I'm not sure. That could be it. But the point is actually just that it's line 1694 that we were messing with. So I want to edit that file by hand. So select in.eg.go. And I also want to note down how fast this benchmark was. So it says that it was about 1 gigabyte per second, 1058 megabytes per second of data. And it's kind of neat the way that, so the reason that the runtime knows, or the test file knows that like, what does it mean to be a gigabyte of second of test? The way that it works is that I specify how many bytes each benchmark is going to be running over. I can just make it up. I'm going to say, in this case, I know that it's, all of the bytes in the column that I'm inspecting essentially. And I write that down, and then it will divide that number of bytes by the time it takes per loop or whatever. Let's see, is that right? Or I guess it would be multiply it by the number of iterations, then divide by per second or something, and then you get out, the gigabytes or megabytes per second. This thing's running at a gigabyte per second. And then the other number I wanted to remember was this number, 1693. So if I jump to line 1693, and what the code had before is I said call is equal to call of 0 to n. That's the only difference in the old code. So if I quit this after changing that, and then I rerun the benchmark, the question is, will we get the old performance or not? Always the ultimate question. Wait, we cannot do that. I think that's gonna have erased our changes. I guess it didn't. I think we have to run, instead of using make bench, we've got to run go test. I think I have it saved in my bash buffer. Go test. Blah, 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 blah. BNAL78, thank you for the follow. Benchmark, select in, int 64, use cell equals false, has nulls equals false. Okay, so if I run this guy, then I'm hoping that I'll see a speed slightly faster than 1 gigabyte per second. I think that would tell me that that would tell me that my mental model of what's going on is wrong, which is something that's happening a lot, I want to say, but whatever. But the reason that I'm hoping for that is that it wouldn't be something more confusing like binary layout causing the benchmark differences, which does happen from time to time, to be honest. Okay, so we get the same speed. We get the same speed. And let's see, if we scroll way back up when we did that big comparison, do I still have that somewhere? Here's where we did the comparison. So this is looking at the old branch and the new branch. The old branch had 1.17 gigabytes per second. And we're looking at more like this 1.05 one. So I guess I want to figure out the minimal change that will get me back to that higher number, 1.17. That's going to teach me something about what's going on. This is what we have. I think that the main other change is just that we didn't have these lines. So let's get rid of them and see what happens. Delete that. Rerun the benchmarks. That'll really be quite mysterious if adding back the bounds checks restored the benchmark to its original speed. I don't know what that would mean. That would mean confusion on my part. Okay, so as expected, we get the old speed. Can I run the regression test a few times and if you get the same sort of trend? Oh yeah, I mean, I think that it's pretty clear. I think that 10 times thing is really, it does do a pretty good job of getting rid of these random effects. So this is the old code, and you get this 1200 megabytes per second. And then as soon as I edit this one time, to put that thing back, so that would be going up here and adding in underscore is equal to call n minus 1. I think that line of code itself, just by itself, will drop us back down to 1 gigabyte per second. But we'll see. By the way, that whole adventure with trying to run 1178. Okay, so that didn't do it. That seems to be about the same. That's still kind of like that 1.2 gigs per second number. It's a little bit slower, and it's quite consistent. You know, 1.17 kind of 3 times in a row, right? 1.18, 1.17. And then if I add this guy back, which was the original thing that we did, it was kind of looking like this. Then I'm hoping that this one will return us back to 1 gigabyte per second. Hopefully that will happen, leaving us in the realm of effects being predictable. Yes, so we are back at the 1 gigabyte per second. This is convincing, right? I mean, you're convinced, right? It's really quite, you know, it does exactly what we expect every time. You know, yeah, convinced it's stable. Yeah. And again, this is sort of where we would like to look at the generated code. And, you know, actually, since last time when you know, you had me look at Radare 2 or whatever, that was driving me crazy because the binary was so big. I did figure out a way to make a smaller binary, or just to compile these little parts of the code. So I can actually do that using that same gotool compile technique. And then maybe that'll be a way to kind of compare these two assembly outputs, and maybe that will get us somewhere. So if I run, let's see, gotool compile, I think I have to pass it this. Hey, Alan is good, rather. Thank you for the follow. Import CFG, and then I pass in package SQL call exec select in.eg.go, and then I think I also have to pass in call exec operator.go, and then I also need package SQL call exec util.go. No. Utils? Hey, Cream Blast, what's up? So essentially what I'm working on is I'm trying to figure out, this code is part of a database. It's the SQL execution engine for a database. And I'm working on trying to convince the Go compiler that it shouldn't emit bounds checks for certain slice lookups, which is a thing that is used to help create memory safety in the Go language. And you could do that using some techniques to just, you know, teach the compiler to make sure that it's proving in a certain sense that a slice lookup is not going to overflow. And I'm trying to sprinkle these around in a bunch of places because I changed something that got rid of some of them in the first place, and I'm just running some benchmarking stuff, just trying to make this code a little bit faster. I'm seeing some weird effects though. Essentially, I removed a bounds check from one of these functions and I saw it go slower. So I'm trying to debug what's going on with that. pprof flame graph. Yeah, I mean, I can make that happen. I can make that happen. I would have to do it locally, but I can make that happen just because it's cool. So let's see, to make that happen, I think what I would do, I'd run make bench like this, and then make sure I'm running the right benchmark again. So that's benchmark select int 64. The reason I can't do it on this remote machine is that I don't have like web access to it. So I have to do it locally, but I don't think it should really matter. So pass this guy. Okay. Hopefully this won't like completely break my computer. It probably will a little bit. Hopefully the stream will survive. I really do like compiling on another computer, a remote. Hey, Drewski, Drew5KI, thank you for the follow. I like compiling on another computer because it makes the stream not lag. kind of a good thing. But in this case, I kind of got to do it locally just to get that flame graph. Aussie boy, thank you for the follow. Hey, we're at 200 followers, by the way. Thanks, guys. That's it. That's a milestone for me. It's a meaningless milestone, but it's a good, exciting one. Right. So here's the thing. Here's what I wanted to do. Back over on this other computer, the remote computer, if I run -s, I believe this is going to dump the assembly code for just the operator that I care about. Okay, so that was a lot of data. I'm going to write it out to a file called, let's see. So I think this was the new assembly output, right? Get status. Oh no, I guess I don't know. This is the one without bounds checks. With bounds checks. With bounds checks? Without bounds checks? I don't know. I think what we want is this. Okay, so this is going to be the without bounds checks. Without bounds checks .s. Okay, back on my local computer, we got weird stuff going on. Expected operand found 4. Did I edit this? I did edit this. Okay, let's run that one more time. Cream Blast, thanks for the follow, man. Okay, so here is the without bounds checks version. And then if I get rid of this stuff, so put it back to how it was originally, which was essentially this. And then I run the compile again, and then I pipe it to a different file with bounds checks.s. Then I can attempt to look at both of these, and it'll probably completely fail. This is probably where I want to use a radare or something like that. I just don't know how to use it yet. But I think that this hopefully will get us something because I think in this case, what we can do is hopefully look at, we can like search for some, you know, known function name. So select in int64, select in op int64 dot next. This is the body of the code that we care about. And it's even got line numbers. Okay, so this is kind of the dream. This is kind of the dream. I think using this file, we should be able to figure out what's going on. Local computer is still running the benchmark again. Local computer finished. Okay, so now I think we can make a flame graph. So pprof, I think I do -web and then foo.out maybe? No, this is just the non-pprof version. What is it? Maybe is it -html? What is it again? pprof-http. How could I forget that obscure syntax? HTTP. Localhost 8080. All right, check this out. We got ourselves a flame graph. Swift Eclipse 18, what's the best way to learn programming? Pick a project that you want to do. Pick a game, pick like a little mini thing, and try to do it. Use Python, that's my suggestion. So here's our non-flame graph version, and if I click flame graph, was it worth it? Was it worth it? I don't think it was worth it. This isn't gonna teach us all that much. We already know that most of the time is spent in comp in 64, and a lot of the time is spent in this one as well. I personally like this view a lot better. This view makes sense to me. Do you know about this view? This view is actually super cool. So what this is doing is it gives you 2 numbers per box. the flat time and the cumulative time. And an arrow means that it's a, you know, a callee of a box. So this next thing, you know, it's taking 1.14 seconds total. 0.65 of those were spent in itself. So no function calls. And then the rest of the time, so that would be 0.46 seconds plus 0.03 seconds are spent doing these things. This guy only has self time. It doesn't call anything else. This thing does a whole bunch of other crap. And it's red or not, you know, like the more red it is, the hotter it is, the more, I don't know. I've never gotten into flame graphs, to be honest. If there's a view like this, I personally prefer it. The box and node plot. Anyway. Here's what I really want to try to do. I want to look at the difference. So this would be line 1690 has the bounce check or not, essentially. So in the case of with bounce checks, if I go to line 16, or I search for 1690, am I going to be able to figure anything out from this? Very possibly not. So let's actually edit this in the same buffer. So I guess it would be 1692 is the thing that would not have a bounce check in this case. Or it would have a bounce check, rather. So 1692 has some jumps. Check it. It's got some jumps. Tracy? I have not seen this. This seems nifty. People throwing tools at me left and right. I love it. C++. Whoa. I don't know what this is, but it looks friggin' crazy, dude. What is this? Holy moly. Oh, this is kind of like, oh, I think I've used something that sort of looks like this before. You can get something like this in Go using Go tool trace. But I don't find it, I don't know. I like pprof. I guess I just understand pprof super well. So Go tool trace and stuff like this. I don't think this would work with Go, but there's something like it. I just don't find it that useful because we're not doing anything with blocks or anything. It's really just really simple stuff. So anyway, like if we JCC, so if I have a number here on the right, how do I get to the equivalent number on the left? You know, like 2030. Do I just search 2037? No, it doesn't seem to be that. I think, do I have to turn 2037 into hex? Is that what it is? How do I, isn't there like a way to hexify? Yeah, 7F5. 7F5. Okay. What about 2099? What is 2099 in hex? 833. OXO 833. Aha, okay, this is the one that I wanted to see. So this is where we actually panic index, right? If you ever jump to 2099, it means that you're doing a panic. And I guess we do that if, I don't know, this thing is greater than some other thing. It's like basically not possible for humans to read this unless you spend a lot of time doing it. So maybe this form analysis isn't working. Like what I wanted to do is compare this to this other one, which doesn't have the bounds checks, right? If I go to line 1692 in the version without the bounds checks, I mean, yes, I'm not going to find a panic, but like, will I actually be able to see the differences between these two pieces of code? Not really. Not really. I mean, I don't know. I guess. So here's a question. If I run Go tool compile, does it produce something? I think it does, right? Does it produce something? What does it produce? Distinct.eg.o? No. Select in.eg. Maybe it, so what if, can I run radare2 on this? sucker? Does that do anything? Oh man, it does. If only I remembered how to use this from what N. Selecki was telling me. A. It's faster this time, right? This time it's way faster because the binary isn't like 100 megabytes. It's like a tiny little baby binary. Hey, it worked. Okay, so then if I type V, does it give me stuff? No. Give me the Radare 2 skinny. Is this like a tool for elite hackers, dude? AFL? The GUI. Yeah. So I wonder, does Radare 2 work on Macs? Those are just addresses, no debug information. I guess I would have to teach GoTool compile to emit debug symbols. Let's see. GoTool compile debug symbols? I wonder if it's like not going to be enough because like this isn't generating an actual binary. It's just like an object file. So I'm not sure if maybe object files don't have, I don't really know how this stuff works. Dwarf symbols. Oh, this seems good. This seems good. So I'll add dash dwarf. I don't know. I'm just guessing right now, basically. But maybe it'll work. Dash dwarf. Yeah? I need to install Radare 2 first on my Mac because I don't have it. Okay, so AFL. No, it's the same problem. Okay, so what if I did dash dwarf location lists? Does that do anything helpful? I'm guessing it's probably not going to do jack shit. But we'll see. Dwarf inline info records? Like, I don't know, dude. Debug symbol export. This looks like debug the compiler itself, which is not what we want. Maybe it doesn't work. Maybe like the object file isn't enough. I don't know. I don't know. I give up. Maybe I'll actually try to do this off stream, figure it out another time. Okay, so here's the thing. Here's the thing. If we go back to our pprof output, and we list this next thing, what we don't see is any time spent, hold on. What we don't see is any time spent in those new things that I added, right? Like, so that couldn't possibly be it, could it? If I go back up here and I say again, this thing and this is, you know, these are the, I don't think that this really could spend that much extra time, right? That would be crazy because this loop is much more effortful than just these two single checks. So I don't think that that could really be it, but you know, it's always possible. Go test. I need to have the flag. So CPU profile equals foo.out. Frustrating. There's a lot of magic in the line. I mean, is there though? I don't think there's that much magic in it. Maybe there is. So list next. if there was magic and it took a lot of time, then we would see some time here. You know, that's the thing. Like the profiler would notice this if it was in fact spending time here. Async sync, thank you for the follow. I mean, I think what has to be happening is that that decision changes the decisions that the compiler makes for these other calls down below. That's got to be what it is, in my opinion. My suspicion is that it actually is changing what's happening inside of compint in 64. So let's do actually one more thing. Let's edit this back to its original state. So get rid of this stuff. And then we're going to save the profile to another file, and we can compare the two profiles. So I'll run this again, and I'll write it to, I don't know, fast.out or something. Problem is that there's no good way to know what the compiler thinks is idempotent and what the compiler believes to maintain the prior check. No good way to know what the compiler thinks is idempotent. Yeah, I think I see what you mean, and I agree. So this is the 1200 megabytes per second version. So if I pprof fast.out, I list next. So this is actually very interesting. Check this out. So in the fast version, I spend a lot more time in this line, which makes sense. This is the one that eliminated, that no longer has the bounds check. In the version that has no bounds check, this is like 10 milliseconds. And in the version that's faster, it's 110 milliseconds. So indeed, you know, this got faster, but something else must have gotten slower. So what must have, I think there's actually a way to diff these profiles. I don't know if it'll really work for us here. So if I say pprof -- base fast.out foo.out, I think it's going to give me a diff. But it's sort of like an absolute diff, so I'm not sure how helpful it'll really be. So check, I mean, this is actually really interesting. It's saying that I spent, wait a minute. What did I say? The base is fast. So a positive thing means it's gotten slower in my new version. So 30 milliseconds slower for this original check. This thing is a lot faster for whatever reason. In my, wait. No, this doesn't make any sense. I think this is like comparing these absolute times doesn't make any sense. Maybe I can't really draw too many inferences from this. So in the fast one, it's 110 milliseconds for the lookup. In the slow one, I said it's 10 milliseconds. 100, wait. Oh, but I'm looking at different sources. I have to change this. This is horrible. This is horrible. I forgot that this list thing it's actually just looking at the current source code in the file. So this is all kind of broken. But the point is that 10 milliseconds is paying attention to, it's like corresponding to this one in my new profile. And I'm getting 140, 140 for the for loop, 220, 850 for the function call, 200, 200 for the selection edit, versus this one's slower, 300, 750. I don't know. I mean, this actually isn't telling me much because they're quite equivalent, to be honest. It's a bit of a wild goose chase with this because these absolute numbers aren't really helpful. You don't know how much you, oh, I think, I mean, I trust these times. You check the bounds once, shame on me. You check the bounds. That's funny, dude. I personally do trust these timings because I've just used this tool so many times for cases where it actually works. I do trust it. I think what's not trustworthy is comparing the two profiles because it's absolute times, not relative times. So I think that's, you're totally right that my methodology is busted. That being said, okay, here's the thing. Can I figure out anything about what this function is doing? Like, I don't think this function is doing anything related to, I or call, which are the only. Wait. Yeah, these two things are really the only things that are like relevant, I would say, in terms of their behavior differences. So I wonder, I mean, could it possibly be passing in bounds check elimination information about call into this function? I mean, I suppose that could make a difference. Target call. Wait, target call isn't even used in this? What is this? Target call. Target LM. Okay, there's no reason for this to be passed in. That doesn't make any sense. That doesn't make any sense. Oh man, maybe this code is just a little bit. Oh, it's used, I see. It's used because in certain cases we do need it for non-native data types. That's a little nasty. Yodrick D3, I think that project's a little bit out of date. What we're doing right now is we're trying to optimize some Go code to make it, well, I thought that eliminating some bounds checks in these loops would make the code go faster. It went a little bit slower because we eliminated the bounds checks, and I'm trying to figure out what the heck could be going on with that and why. That is the project. I can edit it. Commands edit project. Struggling with some bound check eliminations for Cockroach DB's execution engine. How about that? Oh, you used Cockroach at your last job? They went out of business, but Cockroach was amazing. Thanks for all your hard. Thanks, dude. I'm sorry to hear that your last company went out of business, but that's super, super cool. That's exciting. It's very exciting. I hope you carry your good opinions on to your next job, whatever that job might be. Yeah, so I mean, for this one though, like we don't use target call, we don't use I, so I don't really see why. Okay, here's a question. Here's something that we could actually do in our assembly. We could check to see whether that code got inlined or not. In fact, there's an easier way to do that. I want to see whether that function got inlined or not. Go tool compile. Cockroach was your secret weapon for doing a global distributed infra deployment. It was so easy and worked really well. Dude, oh my God, you're like a shill. I love this. Like I need this quote. I need this quote from you. That's amazing. That's so good to hear, man. I'm really happy. It makes me feel good. Go tool compile, import, blah, blah, blah. So if I pass GC flags equals -m, no. Maybe it's just -dm. Or maybe I just pass it -m. Yeah, it's just -m. Your bicycle's calling your name? Enjoy the bike ride, man. Thanks for hanging out. Talk to you another time. Enjoy your bike ride. So this -m thing is like another way of printing out optimization decisions. I think it's like a simpler one, maybe before the Go SSA stuff came out. And you know, I bet there's probably a way to convince the Go SSA or the like SSA debugger thingy to print out inlining decisions. But I don't know it. That would be kind of a cool thing to learn though. Hold on, SSA, where is it? SSA check BCE. So how do I learn all of the different invocations of this? I wonder. Golang SSA debug. Maybe debug flags I could search. This looks complicated. Debug flags. Maybe I can search debug GC flags. Yeah, like what? Everybody puts this SSA check BCE thing, but like, how do I see the list of all of those? I wish I knew. I wish I knew. Anyway, I guess I'll just do it the way that I know how, which is using the -m flag. No. Okay. Third time is the charm. Maybe the fifth time is the charm. -m. Okay. So I want to see whether or not we inline this function that's called comp in int64. Comp in int64. So it doesn't seem like we inline it, and it says that this is line 1597. Select in ego 1597. Oh, that's the function itself. So where we call it is line 1694. Do we get any information for line 1694 in this output? Doesn't look like we do. Okay, well, I guess that doesn't really tell us anything. I don't know, this is perplexing. It's quite perplexing. So let's do one more thing. I'm gonna look at that assembly code one more time. So I'm gonna look at the one with the bounds checks. And I'm going to go to line guess it was around 1694, but not exactly. Comp in, yeah, so here I have call comp in int64. Okay, well this doesn't really tell me anything. I don't know, it just tells me that it's not inlined. We actually do call it. We jump to some function somewhere and that's the end of it. So, I don't know, I mean, what option is that we just like don't make this change? It's unsatisfying, but are these the SSA flags? Maybe. Thanks for tracking that down. These aren't exact. This is interesting. I don't know what this is. This isn't exactly what I was looking for, but this is quite fascinating. I think what this is opcodes in SSA. I think what we'd want to do, this is a good point. We could be searching the Go tree. I think what we'd want to do is search for check underscore BCE and see if that shows up anywhere. It's weird. I mean, it shows up exactly once in an example. So, I mean, that can't really be where it's defined. JB Pratt, what's going on? Azafaza 123, thanks for the follow. Yeah, I wish that there was a list of these things. Enjoying the stream? Thanks, man. Yeah, but it's like kind of weird though. It's like, how can it not be defined here? Maybe it's just like, maybe it's like check underscore was defined and then there's a, you know, a string. No, I guess not. What if I just search BCE? Oh, this looks interesting. How about this? Ooh, it replaces spaces with underscores. Check it out. This is, okay, this is the dream. This is the dream. Passes, the list of passes. We've got check BCE, we've got branch elimination. Probably there's one for inlining too, right? Inline. No? Okay, there's none for inlining. Okay, I don't get it then. Inlining must happen somewhere else. Or it's just like one of these passes that's not called inlining. How can there not be anything called inline in this whole function? Rob Moore, what's up, man? How are you doing? How can there not be something called inlining in this entire file? How can there not be a compiler pass that does inlining? Maybe it's just like opt. What happens if I run this with opt, just out of curiosity? Where was the last time I did that? I guess I can. Why am I so noob? It's a good question. Mosa LBG. I am noob. We're all noob in our own ways. Okay, so this is where we did our little check BCE. So if I pass now, instead of check BCE, I passed opt. I wonder what we would get. Analysis.log. It's empty. Didn't do anything. I guess maybe there isn't just always a mapping from this thing to having outputs for it. I don't know. I mean, this is just like Go compiler internal guts. It's not really that important, I suppose. All right, here's what we're gonna do. Because I'm perplexed on this one. I wanna check out a different instance of this bounce check stuff and see if that one is a little bit more straightforward. So we're gonna go back to our commit where we changed a bunch of stuff. We're gonna go past select in. And we can look at selection ops, which I think has exactly the same problem. So if I look at selection ops.eg.go, this is like a giant file, by the way. This has selection ops is like where all of the filters for SQL are implemented. So if you've ever, this file is actually so big that my IDE has a problem loading it. It's got 59,000 lines of code in it. And of course we didn't write this code by hand, we've generated it. Which is another thing that we like to do on stream, edit this code generator, but that's not what we're doing today. So for example, if you ever wanted to filter a integer column, like select star from table where I is greater than 20 or something like that, that is going to get run by one of these selection ops. So maybe I can search for less than cell lt int 64 int 64 const op. So this is the operator that compares a dynamic int 64 to a constant int 64. And the way it does it, well, it's got a bunch of different switches, but the one that I wanted to look at is this one right here, because this one is doing the same old pattern that we're used to, which is doing a loop from 0 to n and pulling out a value at the ith position of a vector of int64s. And I believe that in this case, we're not getting a bounce check elimination because we don't have a special magic line of code. So let's first just verify that that's the case, again, like we've been doing. Instead of passing check BCE, or rather instead of passing select in.eg.go, we're gonna pass in selection ops.eg.go and write that out to analysis.log. This one's gonna take longer, I guess, because it's such a big file. And then if I run my viewer, so view annotated file analysis.log, and then go over here to where I had this window, we can close this whole window out, refresh this page, and then go to selection ops.eg.go. Dvorak? No, I don't use Dvorak. I think, okay. So I think all of these tools just kind of break down when the code is so big, which is really unfortunate. Like this HTML file just takes forever to load, but I guess it's okay. So we're looking for line 25,469. So I'm guessing it'll be like here, about halfway through the window. 25, oh, that's pretty good. 25,469. So 25,472 is the line that we don't want to bounce check, but we do find a bounce check. So we want to murder this bounce check. That's our goal. So ultimately what we want to do is introduce a thing right here that says call equals call of n-1, which will do it. But we want to do it a little bit higher up because it's going to get reused by a couple of different spots. So we can put it way up here. But of course we can't just edit this generated code because this code is just going to get regenerated. So we have to edit the source of the generated code, which is in selection ops template.go. This is where we define the code that's going to get rewritten a million times in that huge file, once per typed pair. And it looks like we have to put the thing that we're looking for right here. So we're going to say, let's see, is that right? Oh, this is probably the non-const version, right? So we want to look at the const version first. That was the example we were looking at. So non-const is comparing two dynamic values. This is just comparing a single dynamic value with a constant. So here we're going to say underscore is equal to, and then we're going to get with, I think it's like L unsafe get or something. No. It's just execgen unsafe get call. Execgen.unsafe get call of n-1. Do we have n at this point? Or not really? Null bitmap, what's up? How you doing? How are the SM64 runs? I think we have, looks like we have n at this point. I don't know where we get it from though. Kind of mysterious. Where do we get n from? What's going on? Where is n defined? Oh, it's defined right here. What? How did I miss that? Oh, it's defined right here. Great. 23-minute PB. Wow, that sounds really fast. Trying to learn 70 star. When are you streaming your attempts? I'm gonna badger you with this permanently now that I know that you're doing this, because this is like my literal dream, to have a friend who does speedrunning. Oh my God, that's like knowing a god. Get your live split set up, dude. Oh my God. All right, so we've fixed our template, and if we rerun, if we make package SQL call exec selection ops.eg.go, that's gonna rebuild our generated source file. And I think we have to go imports W it for dumb reasons. And then we write out to our analysis log again. And then hopefully what we'll see is that line, well, what line was it again? I guess it's gonna be line 25,000. Oh my God, these files are just too big, too big. Cell lt int 64 const ob is what we want. So we're hoping that for line 25,631, we don't see a bounce check. 25, what did I say? 25,631, 631. We do see a bounce check. Oh, it's the same old problem. It's because we redefined call. We have to, okay, we went through this exact same thing last time. So it should be hopefully easy to deal with this. We get rid of this call. And I think actually just that by itself should do it. We can test it out. If we just delete this in the generated code and rerun go tool compile. Hopefully we'll see that line 25,630 now. 25,630. Great, so we don't have a bounce check on line 25,630. Okay, this is the dream. We're living the dream. Let's just quickly make a commit for just this one little thing and then benchmark it on a remote machine. So call exec, remove bounce checks for const selections. Okay, so we'll push this up. We'll go over to this window, which is again our remote benchmarking machine. We're going to git fetch mine. We're going to rebase. Now we just need to find a suitable benchmark. We just need to find a suitable benchmark. Benchmark select. What are the good benchmarks known as? Don't tell me we don't have a benchmark for this. That would be wild. There it is. Okay, benchmark cell LT. In fact, we have a benchmark just for this very operator that we were looking at. That is lucky. It's not that lucky because I kind of knew. But I guess this is what we want to run. So we're going to run make bench. Benches equals this. Just like that. Oh, and we need a package. Package equals package SQL call exec. Okay. So hopefully what we can do is just make sure that this benchmark works in the first place. That's the first order of business. And then we can look at the benchmark before and after we made this bounds check elimination change. And hopefully we'll see a difference, right? That's the hope. I'm actually, yeah, so there's this other slight problem that I'm encountering in life right now, which is that my stream alerts are broken. I've heard streamers complain about this before, and now I know the pain. The pain of having your stream alerts broken is really a deep pain. Because, well, that's just part of the importance of a... Okay, so this seems to have worked. We're getting like 4,200 megabytes per second for this simple case. So I think what I'll do is I'll run this, benchmark script thing that's going to compare across two branches. And hopefully we're going to see that a difference actually was made. Hey, Burrito Shake, thanks for the follow. Sorry I don't have that hot stream alert, but you can make do with just my sound of my soothing voice. Scripts bench. And then we need a SHA for the last commit we were at. Broco 668. Is this Adam? No. Well, right now I'm just using a terminal. But I use IntelliJ or Golang, depending on what you want to call it. Wait a minute. What happened to my scripts bench invocation here? Okay, so if I pass this and then I pass in the name of the branch that I'm currently on, delete range, then I run it. What this is going to do is it's going to run the benchmark 10 times, once on the old branch and once on the new branch, and it's going to compare the times of the benchmark using some very basic statistical analysis to throw out outliers, and it'll give me the difference, and along with the confidence that the difference was not noise. And then using that information, I can figure out whether the stuff that I did helped or not. Broco, thanks for the follow. You've been meaning to get into coding because your older brother says the job market pays well, LOL, but I'm sure it'll be something I'd take a liking to. Yeah, I think you very much... I really like programming quite a lot, as you can tell, because I'm spending my Sunday waking hours doing a programming stream. I think I personally like it. I got into coding in, I guess, high school, basically. I don't know if you're in high school or something yourself, but I first started just basically because I played games. I like to play Halo 1 on the PC, and I joined a chat room with a bunch of other people who played Halo 1 on PC, and they were like making some scripts and stuff for their chat rooms. And I think that might have been like one of the earlier times that I looked at programming, just like messing around in this chat room, trying to make funny jokes, essentially. But that was a long time ago. I don't know. 21 in college. Yeah, you should start, man. Check it out. Look, I think a lot of people join this channel and ask what programming language should I look at first. My personal opinion is that Python is a great language to look at first, because I think it's pretty simple to learn, and it's going to give you a good foundation for many other languages. It's got a lot of different paradigms inside of it. Object-oriented, functional, non-functional. What do you call just like a C-like language? I kind of forget. There's like a word for that. Just like a simple straight line code. Imperative. There you go. So imperative programming, right? So Python's got it all. Yeah, Cream Blast. Thanks. So I like Python. I think you should check out Python. There's a really lot of good resources online these days for learning to code. Okay, so our benchmark is finished. A C-like language, that's Go. Yeah, Go is kind of like C, Spartan. Okay, so what are the results? The results are that we see a big speed up, 20% speed up. That's a lot for this simple case. But we see a small slowdown in the cases with selection vectors. I don't know why that would be, but we can investigate. So a selection vector is kind of like the thing that we use in the database to keep track of whether somebody else has filtered out rows before us. The way it works is that it's a vector of the positions in a batch of rows that are usable. So the things that haven't been filtered out. And so what that looks like in the code, let's see. So cell int64 const op. No? Is it capital S? What? Cell LE int64 const op. Haha. Yeah, exactly. I wish that Go had macros too. I think Cream Blast, if you stick around for another stream, so probably next Friday or next Sunday, I'll get back to the project that I've been doing for the last couple of weeks, which is working on this thing called execgen, which is essentially a macro generator that I've been working on for this code. Or it's sort of like a mini compiler, mini transpiler, monomorphization engine. But that's we've been doing a lot of work on that thing in this stream. Yeah, Rust does have macros. I think Rust would have been a great choice for a program like this. There's other reasons why we didn't use Rust in the database. And we're sort of stuck with Go for various reasons. But you're totally right that if I was going to start from scratch on this and it was a standalone project, I definitely would have liked to use Go. That would have been sick. Yeah, lots of languages do have it. Okay, so the case where we do have selection, let's look at the worst case, I guess, which is the -8% speed down. So this is the case where we do have a selection vector and we don't have nulls. So I guess that would be down here. And why? I mean, this is, again, the most perplexing stuff about this project is that, like, sometimes when you change just a little thing, this is what I was dealing with earlier before I started moving on to these selection ops. I was looking at a thing where I got rid of some bounce checks and stuff got slower across the board. Now it's sort of like more what I would expect. It got faster in the part that clearly has a difference, but a little bit slower in the parts that I didn't really even edit. So I don't know why that would be, you know? So Black Martian, thank you for the follow. So in this case, we have to have a bounds check because this I inside of cell could be any old int64. So we always have to check whether that int64 fits into call or not. So there's nothing we can do about this one. And then down here, this is the only other index that we do. We're indexing into cell with IDX. Now IDX this is another thing we can do nothing about. So IDX is an integer counter. And every time that we find something that passes the filter, we increment IDX. But again, according to the compiler, IDX really could be any value. We have no idea how many iterations of this loop we're going to run, according to the compiler. So there's no bounds check elimination that we can really perform on this one either. Unfortunately, that's really all the leverage that we have in terms of bounds check elimination. And again, the only change that we made is really this. So I don't know why stuff like this ends up changing. It's really annoying. I guess one small difference, I doubt this will do anything, but if I say call, if I slice call to be of length n explicitly like this before doing anything, I really don't think this is going to do anything. Anyway, let us just attempt to run just that little sub benchmark. So that would be go test bench. And we're going to pass in just that one use case that got slower by 10%. So cell LT int64. Let's be careful though, because I think we just edited the one for LE and not LT. Speaking of macros, this would be nice if we reran the macro that generated this stuff, but since we didn't, let's just make sure. Oh, we did edit cell LE. Oh, we want to be doing cell LT. So cell LT and 64 and 64 const op. Running this on GCE. Yeah, this is on GCE. What's up, Scythe, by the way? How you doing? Nice to see you. All right. So we're going to say call is equal to call 0 through n. And then maybe it'll get faster this time around. Yeah, I think running the benchmarks on the local computer that's doing the streaming is never a good idea. That is for sure. Jet lagged. Yeah, that's a long flight. Back at home, you with your family and stuff. So we're getting 3.87 gigabytes per second, which is the slow one. So that didn't help anything. It's not that surprising. Yes, sir. Cool. Cool, 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 cool. So 3.87 gigabytes per second versus 4.25. I mean, it's just a lot slower, isn't it? Why would that be the case though, you know? Let's look at our CPU profile just since we're here. pprof fast.out. I don't know why I called it that. It really should be slow.out. If I type list next, init bruv. So if I list this function in my profiler, I see, where do I see the time being spent? I see it being spent in this range. Nothing I can do about that. I see it being spent in pulling this argument out of call, which, yeah, this is gonna be slow. Or it's gonna take time, it's not gonna be slow. What am I saying? And the rest of the time is spent doing this comparison. But like literally none of this is something that I could have possibly affected. I don't know, I guess I'm gonna chalk it up to binary differences. You guys, it changed because the binary layout changed. So there's nothing I can do, sorry. GG no re. Nothing I can do. And there's one big thing I could do, which is to change this comp result thing to not have to do the cases that I don't need. Like all I really need is this one. I don't need this else if, but that's a bigger refactor. And that's sort of more on the thread of work that I need to do to make execgen better. So I'm not gonna get into that really. That would make it go a lot faster if I just did a single comparison instead of two of them, but I'm not prepared to make that refactor right now. I'm really only doing things that are related to bounds check elimination. I don't know, maybe I should just call it, right? It's like, reduce the username in the system, it will make it faster. I don't know what you mean by that. Maybe I just call it, you know, like, is it the case that like a 20% speed up is worth a 10% slowdown on another one? I don't really think so, but. Dude, this is BS though, I have to say. It's just complete BS. I think there's some lessons here, you know? There's some lessons. Like, perhaps there's a lesson that these inlined, like, there's no need to actually inline these for loop bodies. Like, this whole thing could be a function, and it wouldn't be any slower. Maybe that's something to try, since we're messing around here. Maybe that's something to try. Like, I could convince myself that that would be a good thing to do right now. So, like, instead of having this be a... Oh. Right. It's because our old style templater can only do inlining. I can't make a non-inlined function that isn't... I can't make a non-inlined function that's templated. I don't think. This is just the pits. A researcher in UMass found that the length of characters of the users in the OS affects a program's performance as it takes that in the n variables. That's not that surprising, I guess. Hey, Skyblue, thank you for the follow. I don't know what to do about this. Maybe I should just say I don't care and move on. That would be something to do. Okay, so I want to look at the non-const one next. How about cell lt int? So this is the case where we're comparing two things, or one thing with a constant value. But there's also, of course, a thing where we're comparing two column values together. So could I put the bounds check in an if statement? So here's the thing about these bounds checks. The bounds checks are actually getting emitted by the compiler. So they're already, it's sort of like they're either there or they're not. We don't directly control whether there's a bounds check or not. So let me actually show you an example on Godbolt, since I don't know, I just think this is so cool, so I don't mind taking some time to look at it. So check this out. Here's a function foo, the very simplest possible function that does anything related to this stuff. It's going through a column, so a slice of int64 of unknown size. It's looping from 0 to n, where n is some arbitrary integer, and it's setting some value that we're passing into the function at every value in the column, so from 0 through n. And so this is what I mean about bounds checking. Since the Go compiler cannot prove anything in this function about the length of C, every time that we do this set, it's got to check, is I greater than the length of C or not? And you can see that it's actually doing that. Now, by the way, this doesn't make sense to me because like the compiler could do this optimizations that I'm doing by hand. I'll ignore that. I'll get back to that in a sec. But check this out. So if I hover over this line here, CI equals V, and I look at what gets highlighted in the assembly over here, I can see that part of what it's doing, besides just this move Q is the main thing that it's doing, like setting CI to V. But it's also doing this other stuff. And what this other stuff is doing is it's checking whether I is greater than the length of C or not. And if it is, we jump down to PC67, which has this panic index thing. So that's what I mean by bounds check. It's like an extra set of assembly instructions that take time to evaluate, that are checking conditions and jumping if the conditions are held. Now, if I do this elimination thing that I'm talking about by manually telling the compiler, hey, please take a look at the n-1th thing in C as the very first thing I do before the for loop, then it's going to put the bounds check up front. And it's going to say, hey, is n greater than the length of thing, then panic. But the actual assignment here, which is this line, it's just this nice tight move Q. It doesn't have to do any checks at all. So this is sort of like, here's another thing though, like the compiler should be able to infer that since I'm doing this basic for loop, it should be able to put this up above the for loop, just like I'm doing, but it just doesn't have that optimization, I guess. So Spartan GTR, okay, so if I declare a var that's a slice, like var data some type, can I make another slice inside a function and assign the slice from the function scope to the global var? Declare a var, yeah, assign a slice from the function scope to the global. Are you saying like var global slice int64 and then like, is this what you're saying? Like C equals global slice or something? I'm not sure what you're saying exactly. I mean, you could do that, but it doesn't exactly, whoops, come back Windows. I don't like when my computer does that. I don't know. Maybe I'm not following what you're saying, but I don't exactly think it helps what I'm looking at. So local scope is equal to then update global slice. I could do that. Yo, bro Hanser, what's up? I could do that, but I'm just not sure that that would really help my situation. In fact, it wouldn't, because unfortunately, part of this stuff is that we're not doing any allocations. That's part of the tricky business about this whole thing, is that allocations are banned from all of this code. What am I working on in this surprise stream? Oh, sorry, Spartan GTR, my bad. Yeah, you can absolutely do that. Yeah, you can totally do that. So in order to do that, what you would do is say, so local blah is equal to make slice int64, 100, and then I'm totally allowed to say global slice is equal to local blah, like you're saying, I'm totally allowed to do this. And it will do exactly what you said. It's going to point to the data inside of local blah, just as you're saying. It may not be what you really want to do for various reasons. Like it's not going to be particularly thread safe, for example, if global slice is referenced by multiple threads, but you probably don't care about that. This is very valid though. What am I working on this surprise stream? So what I'm doing is, well, I can exclamation point project you, which might kind of help, but it probably won't since you know too much. What I'm doing is attempting to, so here's the thing, right? We were doing that whole mess around with templating and thinking and freaking out about whether or not it was the right direction to move for this stuff. And one thing that I noticed is that no matter what, whether or not we do the templating with execgen or the templating with the go-to generics draft, there's one thing that we do not need, which is execgen.range. It's just not necessary. So what I did before was make this commit that just completely gets rid of execgen.range and replaces it with an ordinary for loop. That's what this commit is. And so what I was going to do on stream and what I've been doing for the last couple of hours is going through and making sure that there aren't any missing bounds checks from these, or rather missing opportunities to eliminate bounds checks from the loops that come out of this change. And so I think it's been working okay. We've gotten some weird surprise results though, such as the following mysterious output. The mysterious output is here. So this is a, how am I doing flat bytes range? Okay, so yeah, we just don't use the range keyword at all. We don't use the range keyword at all. We just use for I equals 0, I less than n, I plus plus. So that works with anything, because of course you're gonna have a loop index and da da da. Is execgen range particularly slow? So execgen.range isn't a function. It's just like a directive to this template engine to replace it with a type specific method of doing a range loop, which is really confusing, but I'll show you what I mean by that in this diff. So check, you see this red highlighted code here? This is what execgen.range would be replaced with by our templating engine. It would either be for I is equal to range blah, or it would be, you know, I is equal to 0, I is less than n, I plus plus, depending on the type of the thing that we're ranging over, because some of the types that we're ranging over aren't native slices, and only native slices you can use the range keyword with. Does it produce slow code? It doesn't produce slow code, but it's overly complicated is the trouble. That's why I got rid of it, because it was just kind of, I don't know, the more complicated stuff that you have, the harder it is to make the sort of next generation template engine that I'm trying to work on, if that makes sense. I don't know. I think it's a good decision overall. It's just, it does require a little bit of extra elbow grease, which I'm working on right now. But it's fun elbow grease, I want to say. I like doing this bounds check stuff. Anyway, so here's the surprise, Brohanster. The surprise, which is unfortunate, is that I added this missing bounds check to this selection const operator. And as you can see, in the case that I added it to, everything got nicely faster, 20% faster, in fact, which is pretty huge. A 20% speed up is nothing to laugh at, but some other cases got slower. So one case got 10% slower, and that 10% slower case I didn't really even edit. So I tried to look at it. I didn't really find anything suspicious, so I'm chalking it up to binary layout, which is the most fun thing to chalk stuff up to because it's something that you can't really affect. So GG, binary layout, nothing I could do. Sorry, goodbye. Okay, so the next one I wanted to check out though was this non-const selection stuff though, which I'm pretty sure does not has some missing bounds checks itself. So let me show you what I'm talking about. If I look at cell lt int 64 op, which I guess I'm already looking at, and I look at the simplest case, which is where we don't have nulls and we don't have a selection vector, which is down here. Then check this out. We're looking at two columns, and we're indexing into both of them with I. And I'm guessing that one or both of these things has an unnecessary bounds check. So I want to verify that now. And I will do that by looking at our analysis.log file. And now, where is it? Oh, it was on the local computer. Vim analysis.log. So I want to look for line 25801, 25801. Oh, okay, so we don't have a bounds check for 25801. Ooh, but it looks like our line numbers are kind of off, so we need to rerun our analysis. I did find an easier way to look at the assembly. I did. It's all about this go tool compile thing. This is actually such a sick thing, though, you guys. It's that you can run go tool compile on a specific subset of files within a package, and it will only generate the object file for that part of the package without any of its dependencies. So it's a very tight little thing. If I ran -s on this invocation, I would get assembly just for these 3 files, which is super solid. But you do have to specify like the right set of files, which is kind of hard. Like if I just did selection ops, it would be like missing defs. So I have to like find the files that it references essentially. And you also have to pass in this weird import CFG thing, which you have to like craft. It's this like giant file that's got import maps and stuff. I don't know. It's like slightly a pain, but it's no big deal. Who is going to be the first person you hire off of the stream? I don't know. It could be you, Robe. It could be anybody. I don't know. So, does it not handle patterns? The go tool compile thing, I do not think it handles patterns. I think it would, I mean, Bash would handle the patterns for me, but I wouldn't want that. I don't want, the whole point is that there's so many files in this package that I only want to specify like 3 of them, because otherwise it generates just too much output. Okay, so I've rerun my analysis. I look at my analysis. I look at line 25801. Wait, I search for line 25801. So I find a bounds checks for 25801, but none for 25802, which is kind of weird. I mean, it just means that like we sort of bungled this, whatever the heck is going on over here. It's just bungled, fully bungled. So let's fix it. I've learned some things about bounds check elimination since when I wrote this code. I think that's sort of the conclusion. The thing that I used to do, which is to slice the things with the length, it doesn't really work. What you want to do is just the dump thing and assign something to, you know, underscore. That's for some reason going to be the thing that fixes it. So I think what I can do is say underscore is equal to call one dot, or I'll say rather execgen dot unsafe get call one and -1, then the same thing for call two. And then down in cell loop, I can actually just get rid of these slices, which are like fully pointless. Where are they? This whole stuff is like completely pointless. What? Slice is a no-op for byte type, so it might contain an incorrect value? That sounds horrifying. I'm just gonna delete all of this because I think it's unnecessary. Okay, so we'll do that. We'll run make. So we have to do a couple things. We have to remake this file by running the template engine on it. We have to go import it for stupid reasons. Then we have to rerun go tool compile on our set of files. And then at long last, we can look at our analysis log. I think we do have to refresh our understanding of the line numbers though, because they probably all changed. They certainly did. So cell lt int64 op. And we're gonna go down to where we're doing this comparison. And we see just what we wanted to see, which is we're setting these, there's no weird slices up above, but hopefully way up above, we do see, yeah. So these are the bounds check eliminators, the magic bounds check eliminators that we care so much about for some reason. Okay, so now the dream would be that there is no entries for 25.327 or 25.328. Let's see if the dream is alive. What did I say? 25.327. 25.327. All right, we're living the dream. What about 25.328? Okay, we're living the dream, you guys. We are living the dream. There are no bounds checks for this stuff. Pog, 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 mega pog. Okay, so let's make a commit for it and then run the benchmarks to see if anything changed. So we'll say call exec, remove bounds checks for non-const selection ops. Selection ops. Release note, none. Push, get fetch. Whoops, I guess it's not. There we go. Okay, so now we just have to find a benchmark for it again. I think there's a benchmark called systematic way to do this for my removal, the systematic way is just like me doing this by hand. I mean, I think I could do it a little bit faster if I wasn't doing it on stream, but I find it kind of fun to do it in this sort of slow way. So it's cell lt int 64 int 64 op. This is the benchmark we want to run. Pretty similar to the other benchmark, it just doesn't have the const on it. So I think if I run this guy here and just get rid of const, we should see something good. Oh, not regressing. No, there's no way. There's no way. We'll have to just do a big bench diff. Yeah, that makes me sad. The big bench diff, I think it might even like be too big. So if you run it, it might take like more than 30 minutes. It'll time out. You'll be really sad. I need to figure out a way to improve that. But I don't know how, honestly. There's just so many benchmarks and they all have so many variants. It's just inevitable that there's a lot of things to compare. All right, so the benchmarks are running, which is great. We seem to have 6.6 gigs per second on the simple case. So I guess the next step would be to compare. Is execgen open source? Yes, all of this code is open source. It all lives in cockroachdb cockroach. Execgen inside of cockroachdb cockroach is under package SQL call execgen. So that's all sitting on, I think if I do this, it'll give you a link to the cockroachdb repo. All right, so what was I gonna do? I was gonna run this scripts bench thing like this, except I've got to change some parameters. I've got to I don't know, why am I so slow at this? Unclear. Run this, and then I guess I need to put a SHA to run before. And then I pass in delete range. And then I think what did I do wrong? Oh, I didn't put scripts bench in there. Scripts bench. Okay, so what this is gonna do is it's gonna check out that old branch, run the benchmarks 10 times for benchmark cell lt int64 int64 op, save the results, switch to the new branch, run them again, compare them with some statistical analysis to throw out outliers, and then give me the results. And using that, I can figure out whether or not I made a difference. I'm hoping I will, but we'll see. We shall see. Sun's going down. The golden hour happened on stream, which I love. And now it's getting darker. Oh, check this out. I think I don't know if you can see this on the stream, but if I go to my phone and I say, "Hey Google, turn on the light," it turned on the light. Did you see the color change in the background of my face? Probably not. It's not dark yet. Has there been any talk in the Go community about exposing an unsafe get to slices? We were talking about this earlier on stream. I could do that. I mean, I could change it to be unsafe get on the slice and it would go faster, but like I don't want to, because realistically I like the fact that I have memory safety and that, bugs in the code won't cause like memory corruption. I don't want that. That would be horrible. I only like to do it when the compiler proving things that, the fact that the compiler has the ability to prove these things is really important. There is a compiler flag to not do bounds checks, but I don't want to set it. That would be horrible. I mean, that would make it so that all of those panics that we see in the wild turn into memory corruption. Which really would be bad. Really, really would be bad. Yeah. All right, so these benchmarks, they're running. Hey, they finished. Okay, so what is the results? This is what I'm talking about, you guys. Best case would be fail to compile if you have to omit a bounds check. So this is the sort of BS that I'm dealing with right now, you guys. This case got 30% slower. Like, anyone care to explain this for me? Is bounds check elimination pointless because things just like randomly get slower for no reason? I just don't. I don't even know, man. What if I just run the single benchmark? Do we still see that same problem? No, allocations are all equal. Look, it's not that. It's just like you get these weird effects. I've been seeing this entire stream. You get these unexplainable effects that in the past certain people have told me are due to the way that the binary is laid out. You get weird effects because of that. I don't love that explanation because like that makes absolutely no sense, but it's probably true. Time to inline some assembly. That would be kind of interesting. I mean, that is something that I'm interested in looking at eventually because the whole point of this engine, this call exec SQL engine, is that everything's lined up in columns so that you could theoretically use vectorized operations in the CPU, like the superscalar CPU instructions and stuff like that. But we haven't done that. Go doesn't emit those automatically. But I could, and if you wanted to make that happen, then you could by making some inline assembly. But I don't want to do that just yet, because imagine how much harder everything would become if all of a sudden we were also generating inline assembly and messing with that and stuff as well. Yeah. Too large of a change for binary layout, does it? Okay, so let's look at the difference. Let's look at the difference. All right. This is the challenge. We're gonna copy package SQL call exec selection ops.eg.go to slow selection ops.eg.go. I mean, you know what we haven't done in a while, actually? Hold on. We haven't run this view tool. This tool is really cool, you guys. Check this out. So if I run view annotated file on analysis.log, and I go over here to localhost 8080, I refresh. The problem, yeah, what this gives me is a drop down of. So what this file is like, it's gonna give me the the code of all of the files that I've compiled, along with whether or not I had any checks, right alongside the source code. It's pretty sick. So if I then go to this selection ops eg.go, the problem is that this file is really huge. It was working really well on stream earlier with the smaller files, but this one's just like super massive. But it will show me eventually, once it finishes loading, that all of that code in line with its bounds checks. So if I search then, I mean, we can look for a simple one. Let's just look at cell eq bool const op. Or no, I guess we want to see cell eq bool op. So the one that got 30% slower, right? That's this one. And as you can see, we don't have any bounds checks except for setting the selection vector down below. So what's so perplexing is that, before the change that I made, these two did get bounds checked. And for whatever reason, the fact that they don't seems to make some other stuff slower for no reason. I don't know. It's confusing. I mean, I guess one change that I did make that I don't have to be making. Let's edit it on this computer. Selection ops.easy.go. And then we're going to go to cell LT, int 64, op. So one change that I did make, I mean, I put these guys way out here. Like, I guess there's a chance that I shouldn't, and I should just, what happens if I just put them right above where they need to go? Let's do that. Let's rerun our benchmark. See if that does anything good for us. I don't know why I would, but it's worth checking. Because that's where the sort of slice style bounds check eliminations happened before. Hey, Dr. Vem or Vern, thank you for the follow. Is that a Vem or a Vern? Can't tell. Looks like a Vem. Dr. Vem, thanks for the follow. All right, so we're still in slow mode. 6 gigs per second. Vem is equal to Vim, but that was taken. Dr. Vim, dude. Are you a Vim fan? I like that. All right, so we put this stuff back. I mean, you know, it just doesn't make that much sense, realistically. So what did the old code exactly? What about the code that I deleted? Yeah, we can put that back. So what that did, let's copy it. What that did is it said call1 is equal to call1 0 through n. It said call1 len is equal to len of call1. Then it said call2 is equal to call2 of 0 through call1 len. Why did it do it this way? Because I thought that maybe it would convince the compiler to do some black magic stuff. Okay, so we're restoring the code to be exactly how it was before my change, at least for this one little branch. We're gonna rerun the benchmarks. If it's still slow, then I'm convinced that it's binary layout. I should probably sub to Primogen. I've watched his stuff. I don't know, his stuff is intense. He does some cool stuff with Vim. Vim Royale. Dude, is Rohan getting trolled right now? Yo, Pandawine, thank you so much for the Prime sub. I'm sorry my subscription alerts aren't working right now. But thank you so much for that Twitch Prime subscription. Dude, that's hilarious. I need to get like TTS working, because what you put there would have been a pretty good TTS spam. Okay, so in this case, we get a 7 gigabyte per second output, which is still less than our original output. I don't know why. Prime is a fantastic host. Yeah, I like that guy. He keeps it fun. I think it's quite fun to watch him program. So what's the deal, right? Let's copy this thing again. Copy. So we're gonna call this, I don't know. We'll just call it selection. We'll call it, what would be a good name for this thing? I don't even know. Foo ops. Foo selection ops. Voodoo, right? I told you it's voodoo. I told you it's voodoo. So let's check out the last branch, right? And then let's remake this thing. And then let's go imports it. And then let's go test to see what happens. Whoops, what did I do? I screwed something up. What did I screw up? Does this still have... What did I do? I ran go imports on the wrong file. That's the problem. Selection ops.eg.go. Okay. Rerun our test. Now, I'm expecting that this will be the fast version, so the 9 gigabytes per second version. If it isn't, then that's highly suspicious too. What? I ran the wrong benchmark. I'm getting, okay, here's the right benchmark. Here we go, forget that last number. What is the ErgoMech keyboard you have? My friend, I have a command just for you called !keyboard. Ho! VIP this man. Wait, he's already a VIP. All right, so this is the fast version, 9.5 gigabytes per second. So explain that, huh? It's confusing, right? It's confusing, right? It's binary layout. It's binary layout. It's the only explanation. So what does this look like? The old code looks like this. It does this weird crap. That's exactly, I mean, I put that, right? You saw I put that. TFW bounce checks make your code go faster. I think it's just random. It's just like random. You know, it's, did you get a good binary layout today or not? And it's quite unfortunate. I don't really know what to do about this situation. I don't really know what to do about this situation at all. It's a major thorn in my side. I run into this. Okay, so here's a question. What if I just edited this to be the fast version, right? So if I said underscore equals call1 of n-1 like this. So I get the bounce checks for both of them instead of just one. And then I rerun the test just like that. It doesn't make that much sense. Binary layout affects instruction hit rates, etc. But that benchmark is just this loop. Better vectorization with bounds check. Yo, Pandawan, nice first badge there. Better vectorization with bounds check? But this code doesn't emit vectorized ops because Go doesn't do that for us, unfortunately. So the whole thing where we call this the vectorized engine is slightly made up, but not really. I mean, it's just a different word for vectorized. Okay, so in this one we get, I mean, this is what I would expect, right? Look, we have 9400 and we have 9700 here. So like a small but noticeable difference when we literally just edit this little loop to include the bounce check elimination right above where it's happening. So out of curiosity, what happens if we get rid of that stuff and put it way above over here? Does this help too? You get rid of these. This is just so shitty, dude. I don't get it. I don't get it. Yeah, the benchmark is just this loop. I agree. Right. So it's like you'd think that the instruction cache or whatever, it's all still going to be local anyway. So why would it really be any different? I don't understand it. Okay, so let's run these benchmarks. This is kind of where you run into issues with Go. It's a simple language, but digging into difficult stuff is so hard. Yeah. All right, check this. We're back down to 6.5 gigs per second with that little change. Why? Let's run our Go tool compile to see. Wait. Time to move line by line? What do you mean move line by line? But here's the thing, there's no offending line. It's like the aggregate, I'm telling you there's no offending line. But I mean, we can do it. It's a lie. The whole offending line thing is just a lie. It's a lie, it's a lie, it's a lie. So as an example, this current code has no bounds check elimination. Watch this, watch this. If I delete both of these, I'm guessing the whole benchmark will go faster for no apparent reason. So those are just 2 lines. That's like the minimal change, right? I'm logging into my Streamlabs while this is going because I don't understand why my alerts are not working. Test follow. Huh. What's the deal? Nothing in my output here. All right, so benchmark runs. Okay, this actually makes sense. It got slower when I removed the bounds checks. So I mean, I suppose what this is telling me is that, like, I mean, if I trusted anything about how this stuff works, which I don't right now, it would be saying that, like, I need to move the bounds check eliminator thingies closer to where they actually happen. So if I get that back, it was underscore equals call 1 of n minus 1 underscore equals call 2 n minus 1, and I could put those just where they matter. So that's here and here. And then if I rerun, it should go faster again. I think that will actually work, right? It's just that, I don't know. That was cell equals true. Did I screw it up? No, I got cell equals false, both cases. One was nulls true, one was nulls false. I think we're good. What's wrong with my damn alerts? Fresh cache of current page. What about now?
The database's too big. I have to narrow down the search. How are you gonna do that? By guessing.
All right. Okay, watch this. I'm gonna replay some of these alerts because I want to honor you, people. Isn't there a way to do that? Uh-oh, that was the wrong one. What if I hit that? Oh, I don't know how to do this. This is out of my depth.
Databanks,
there we go. Dr. Bam, there is your alert. Okay, cool. So in our thing, we get the fast version. So I don't know, maybe it's worth a shot. Maybe it's worth a shot in our actual template. Instead of doing this way at the top, so let's undo all this stuff that we did. Wait. In our actual template, instead of doing this way at the top, we'll do it inside of our cell loop in the case where cell is false. Like this. Like this. Maybe that would actually make a difference. I really don't think that it would. I don't really think that it would, but there's always a chance that I might be wrong. So we'll git add 1, we'll commit amend. Which was inexplicably slow. We'll push. We'll go over to our other computer. We'll fetch. It's wild, right? It's real wild. Wait, git fetch mine is what I wanted to say. Exactly. I mean, so, okay, here's the thing though. Like, the location does matter because that line of code, it does get executed, right? At runtime, that code has the bounds check. So it will run a bounds check at runtime on that line of code. Okay, so then I'm gonna remake, I'm gonna re-go imports. I'm gonna run go test. Okay, see if I can get my redo that.
Everybody knows
there we
that
go.
Relational database
Pandawine,
scale because
here is your deserved stream notification.
Join, and write to disk.
That wasn't, it was happening for batch. I mean, all this stuff is happening for batch. It doesn't make any sense. I'm telling you, it makes no sense at all. It's brutal.
Everybody
Yo,
knows that
Gate
relational
DLOL,
databases
thank you
don't
for the
scale
Prime
because they use
subscription. Hope you're having a good day. I really appreciate that.
To disk.
Got those pride emotes. I think that I really want pride uwu. Do you have that one? Pride uwu. I didn't get it yet, but it's really, it's like another B. So this is, I mean, look, it. Gated LOL is E8 at FB. Cool, man. Well, thanks for hanging out at my stream. Yeah, man. Thanks for hanging out. Do you program in Go at Facebook? Dude, though. So you saw what happened, right? It went back down to 7.3 gigabytes a second. And the reason that it changed, I think, is that we edited the layout of the other spots in these. I don't know. I can't explain it. I really can't explain it. So let's try one more thing, actually. Let's try one more thing. If we come back over here, we regenerate that output. And then we're gonna edit the code. Wow, what is wrong with it? Oh, we have to run Go imports on it. If we edit the code to remove exactly those two cases that we did. So we changed two cases. We got rid of these. We replaced them with the simpler underscore equals call one, n minus one. And we did that, well, n for call two. And we replaced that in both spots. So one there and one here. Then we rerun our tests. I suspect that this will be fast. And so this is gonna be the non-local effects that I was most afraid of. Right, this is gonna be the non-local effects of all of the other non-int64, int64 ops were changed. And yet, even though the benchmark is only checking that int64, int64 op, the speed is still different because of binary layout. That's my suspicion. And we'll see. If this is a slow speed, so less than 9 point something, that will mean that I am wrong. And if it's a 9 point something speed, it'll mean that I'm right. It's an 8 point something speed. Dude, I don't know. I don't know. Is this just all completely random? Is it all completely random? This machine that I'm running on, it's quite consistent. It's not like it changes. So what if I just leave that? Oh, I put it in the wrong spot, didn't I? Oh wait, no, I didn't. All right, what if I just put it just in the spot that I was editing? I mean, just the spot that the benchmark's running against. The 24 means that 24 thing is like super weird. It's something that Go emits, and I think it has to do with I think it's like the number of CPUs that it's running on. I think. Or something like that. It's like, yeah.
The computer's hooked into over 1,000 data banks throughout the world.
Yo, V-Leet, thank you so much for the follow. Dude, I don't even know. I'm like, how do I look at the number of CPUs? NCPU, like cat, proc, CPU info. Yeah, so I've got 24 cores, so I guess it is, yeah, the 24 is the number of CPUs that it's running on. LS CPU, yeah. So what do I do now, you guys? I don't know what to do. I don't know what to do. And just to confirm, right? Just to confirm, if I go back to my local machine, rerun this thing, re-go imports it, and then go tool compile it, I will for sure see that there's no bounce check, which is the whole point. It's just like, it's not good enough is the problem that I'm running into to have no bounce checks. It's like there's other confusing effects. So the line that I would care about was what again? int64, wait, cell, LT, int64 op. And I want to make sure that 25487 has no bounce checks, right? 25487. Okay, so no bounce checks, but it doesn't matter. I don't know. You want to understand these non-local effects things more? This seems absolutely broken. How does C++ templating not run into this? It probably does. Am I Ron's boss? In a way. I think I might be its grand boss now. Is there such thing as a grand boss?
The computer's hooked into over 1,000.
Yo, Simplex991, thanks for the follow. I don't like the word boss though. I mean, who does? Of course a boss would say that. I don't like the word boss. Unbelievable. What have I become? All right. So again, I'm sort of lost. I'm a little bit lost as what to do, right? It's like, do I want to make this change that's clearly better but makes these local benchmarks worse? All right, here's another question. I have an idea, you guys. This will be sort of fun. Let's go over here, and we're gonna compile Cockroach with this code on this remote machine and run like a by hand SQL benchmark to see if that changes, just for fun, just because we're all hanging out. What is the branch called again? It's called delete range. Delete range. See ya, bro Honsters. Thanks for hanging out. Thanks for the good luck. Well, I'm actually a little bit nervous about something, which is that I might have been on the wrong branch after I push that latest change. It's possible. Only just one. What my words permitted is on that keyboard. Do you guys want to do a type racer with me? I can crush some type racers on this keyboard. All right, so I did the Go imports. I'm gonna run Go test. My words per minute, I don't know. I think it's like 100 something. But I never type as fast as I could, right? Like, who does that? Normally when you're programming, you're not like typing at full speed. You're mostly thinking. I think I'm limited more by my thinking speed than my typing speed. I don't know. So let's just do that just for fun. Okay, so we're gonna make the database. I'm gonna make the database. Okay, well, do you guys wanna, who wants to do a type racer while it's compiling? How do I do this? Race your friends. Okay, if you guys click this, I want to see if anybody's going to join this. Does anybody want to do this with me? I think I did this on somebody's stream once, and I think I crushed everybody on the stream, but they didn't know who I was. Oh, hell yeah. We got a guest entered the racetrack. Okay, so we've made the database. We're gonna run it. Sweet. I'm gonna wait like 5 more seconds to see if anybody else joins, but otherwise we can do it. Let me just quickly run cockroach start dash and secure over here, and then we'll go over to another window, make it a bit bigger. We're gonna script GCE worker SSH, so connect to the same machine. And we're gonna cd go source cockroach go source github.com cockroachdb cockroach. Okay, then if I say cockroach SQL insecure, then I've got a little prompt. So I think if I make a big table, create table A int, B int, I just want to see what'll happen if I, let's see, insert into A values, or select star from generate, I guess it would be select G comma G from select from generate series 1 to stick a big number in here. Whoops, and then I have to alias it G of G. Okay. All right, let's do this type racer. Ready? Start in 10 seconds. Capacity to love. $121. Oh yeah, and then it makes you do a typing test if you are too fast. I don't know. Okay, so we inserted 1 million rows. Is this 1 million or is this? Yeah, we've inserted 1 million rows into this table. And then I want to check how fast this thing runs. So I'm going to say select. You fat fingered so much. Yeah, so did I. I didn't do such a good job. So if I select A less than B from A, I guess I'll say, how do I make it so that I don't output any of these results though? Let's see. Oh, I guess I want to say select star from A where A is less than B. I think this will be the operator that we were just playing with. So it's a scan with a filter, and I think this will return nothing because they're all the same. And so out of curiosity, how fast does this run? 837 milliseconds. But it's so variable. I mean, well, it's not that variable. It's always about 420 milliseconds. Blaze it. So then the question is, if I recompile it without this bounds check elimination, do we see any differences? That would say that if we do see a difference, then it would sort of say that our micro benchmark sort of sucks. Maybe is what that would say. So we'll recompile the whole thing. It'll take a little bit, but it'll maybe be worth it. Maybe. It does take kind of a long time to compile the whole database, but this is sort of why we like to run micro benchmarks, right? It's like we don't want to have to recompile everything and have the performance of this thing sort of depend on like random other factors inside the database. It's not ideal, but just because we are so confused about whether the micro benchmarks are being affected by weird like binary test layout stuff, I feel like it's a good idea, or it's at least an interesting idea. Okay, so we rerun the database, we go over here, we reconnect, and then I think the first one will be sort of weird because it's gonna be refreshing the cache, and we expect this to be slower by a little bit. So the first one's gonna be a lot slower. And then from there on, it's like basically identically the same, about 420, 424, 426, 419. So it's basically like completely the same, and maybe this stuff that we did just doesn't do anything. I guess that's a good thing though, right? It's like this whole point, I don't know, was that we were making a bigger change. We were trying to make sure we didn't add any new bounds checks. And if we didn't, we didn't. We don't need to worry so much. So now I won't come as a guest anymore on TypeRacer. Now my name is John Dix. I live in the Antarctica, and I'm born in April 1910. Okay. That sounds believable. Sounds believable. So what now? I guess there's like a couple more little ones I could do, and then that would be it. So what are the last ones that I didn't do yet? I just did selection ops, and the last one I didn't do was this min max ag temple. So let's look at that one. Min max ag template. Wait, min max ag template. So this is the template file that generates the code for the min and max aggregate functions in SQL, which you might be familiar with, where you can say select max or min of a column. So this is the code that does that. And so the thing that we did in our earlier change was to replace this like range macro thing with just an ordinary for loop because it's sort of simpler. But the thing that I noticed is
Computers
that
hooked into over 1,000 data banks throughout the world.
hey, please compile. Thank you so much for the follow. I really appreciate it. In this accumulate min max function, this thing gets inlined, by the way, like textually inlined. This input or line of code that says a.groups of I, as well as this line here that says this is going to compile into call of I don't think that these things get their bounds checks eliminated. And so I just wanted to verify that and then eliminate them if that was in fact the case. So let's go ahead and do that. So in order to do that, we're going to do that same little dance that we've been doing, which is to run gotool compile with a special flag that informs the compiler to dump its bounds check elimination decisions to a log. So we're going to pass in min max ag.eg.go, which is the name of the generated code for min max aggregate. Wait, that didn't work for some reason. No such file or directive. Okay, I guess I misspelled it. Frizzo73, thanks for the follow. Wait, what? Maybe it gets compiled into a... What is the name of the output of this template file? minmaxag.eg.go. I'm confused. Let's see. So if I ls all of the files in call exec and then grep for min max, do I see anything? Oh, there's one for ordered and one for hash. Okay, interesting. We can just take a look at the ordered one for now. That should be fine. So if I go back to my gotool invocation and pass in, instead of min max, I pass in ordered min max, and hopefully I will... No? Still unhappy? This must be a different thing. Undefined aggregate func alloc. Okay, so I need to pass in some more files. Aggregate func. This thing is defined in aggregate funcs.go, so I guess I have to pass that in too. Package SQL call exec aggregate funcs.go. Still no good? Still missing a couple of things. New any, not null. This one's a bit annoying. I guess I have to pass in all of the aggregate functions or something like that to this. So package SQL call exec, it would be like star ag.eg.go. Maybe that'll help. Oh, then I need to unpass in the one that I already passed in. Okay, this is a little goofy, but it still saves us a bunch of time because compiling this whole package is really quite slow. Okay, so we've got our analysis log, and then if I run this view thing, view annotated file, analysis.log, go to my web browser, get rid of this thing, refresh. Then I see for each of these files, all of the bounds check elimination information, which is the dream. So we're looking at min max. And the question is whether or not we have bounds checks at a few lines. The ones that I guess we care about are down in here. So we're grabbing a candidate, call of I, val is equal to call of I. These are both bounds checked, but they don't have to be because we know that call is less than size input len. I do think that this is a problematic case because it's happening inside of a closure, and I've seen a couple of issues with this, unfortunately. I think the Go compiler has trouble eliminating bounds checks when they happen inside of closures, so I'm actually a bit skeptical that we'll be able to do anything about this one, which is also good though because it means that we're not like making anything worse in a sense. Like it never had bounds checks eliminated even before we made this change. But we can just like verify if I edit the generated code directly. So if I look at min max ag, it's ordered min max ag.eg.go. And then I go down to line 185. Was it? I guess it's this. So if I say underscore is equal to call of input len -1, then ordinarily, except for this whole closure business, which is sort of messing me up, this is going to eliminate the bounds checks. And by the way, same for a.groups. So a.groups of input len -1. Again, this is like, why doesn't the Go compiler do this for us? So unclear. It's such a common pattern to iterate through a slice with a range loop like this, or a non-range loop rather, that I don't know why it doesn't notice that pattern and produce one of these things. It doesn't really make any sense to me, but hey, what are you gonna do? Okay, so if we do that, and then rerun goToolCompile, and then rerun our view annotated file, what do we see? On line 185, wait, we have to switch files again to ordered min-max ag. And we want to be looking at, wait, what, where did I change this? Yeah, it was right here. So we've done the early bounds checks, but it didn't help. And I think that's because the whole thing is inside of a closure. This whole thing drives me crazy. Let me just check that just before I give up here, because I'm fairly sure if I just remove this closure, which isn't like strictly necessary for the purposes of checking these bounds checks, but is necessary for other reasons, then these eliminations will actually happen, which is just so unfortunate. Hold on, did that not compile properly? Min max ordered min max ag.ug.go. I needed another end bracket. Okay, there we go. So one more time, we're going to do goToolCompile. We're going to view annotated file. Going to refresh our view. And then we'll see now if the bounds checks got elided. The answer is still no. That's actually a little bit shocking, right? It got eliminated for the case of call of I, which is good, but not for this a.groups of I business, which I wonder if it's because it's a struct variable and it could theoretically, yeah, that's probably it. Look, so A is a pointer type, right? And so since this groups is to get this, you have to dereference A. So I think the problem is that it can't prove that it's not in fully local scope. So like somebody else could have modified it essentially. So I think if I were to say groups is equal to a.groups underscore equals groups of input len, and then change all of this like this, then I think this is going to eliminate the bounds checks. Let's find out. So we've set groups. Yeah, exactly. Okay, so I guess my hypothesis was right for this particular case, which is that if we know for a fact that A is not being used in a multi-threaded way, so we're the only owner of A. Nobody else can have a reference to A. So we're allowed to do this change. Set groups and only edit this copy of groups, the slice of groups. We're not copying the whole slice, but just the header of the slice. And if we just look at that guy, then it does eliminate the bounds checks here, which is great. However, if I restore this to its original nature of being in a closure, does that, I still think that we're gonna have a problem, unfortunately. Let's restore this whole thing. I think that if it's in a closure, even if we make this change to fix the a.groups thing, so if we say groups is equal to a.groups, do this whole business, I think this is still going to have bounds or yeah, it's still gonna have bounce checks because like of the, whoops, I need to run go to compile because of the issue that I'm talking about with the Go compiler and closures or eliminating bounce checks inside of them. I need to file an issue about that for them because I don't think that it's expected. I really don't think that it's expected. Okay. Oh, but it did get eliminated. But not this one. You know, it's like, what the heck? It's just like, what the heck? It's really, just feels kind of unpredictable when and when not these things are going to change. But anyway, so I think in order to make this change, we would go back to order, or we'd go to min max template. And where we see a.groups, we're going to say groups is equal to a.groups. Actually, wait, no, we're gonna say that. I think we can say that way up here. Actually, you know, we might as well just not change any of this stuff. It doesn't really seem necessary because I think this was going to be broken before or after our change. I don't think we've made anything worse with the change. Like essentially what we had before, we can check, we can validate it. What we had before in our generated code was, actually let's wipe out these manual changes to our generated code. So we're going to remake this thing. Wait, it seemed to have, I think it doesn't know to regenerate it. Regenerate it. Go ahead. Okay. So then I think if we change it back to how it was originally before I made any of these changes to do with range, I think min int 64 ordered ag. What it would look like before was, I think we still need to run go imports on this. Hold on. Go imports -w. Okay. So what this was going to look like before was for I in come on. Not going to use Vim. Vim is like freaking out. I think the Go Vim plugin just like kind of sucks. So I'll just use it in Golang. So I'll say for I in range call. This is what it looked like before. I'm fairly sure that if I go tool compile this, I'll still see bounce checks where I saw them before, which would kind of mean that I don't have to make these changes. Don't need to worry too much about it because I'm not making anything worse on the whole. Switch to ordered min-max ag. And indeed, in this case, let's go to the simplest case. Oh, well, this is, I guess we didn't change the simplest case. This is where we replace the, ordinary for loop for I equals 0, I less than input lane I++ with the for range loop. But we still see bounce checks for a.groups. We still see bounce checks for call. So we haven't made anything worse, which is great. I think it just sort of means that we're good to go with this whole change. So we've made several little commits for this stuff. And I think that it means that we can probably submit all of this without, I think we can get rid of this one too, because it's got the same problem with this perform operation closure. But yeah, I mean, I think there's still like sort of this mystery where like we've removed the bounce checks for these selection ops and things kind of got slower in the micro benchmarks and not really slower in the main code, I guess. I still don't really quite understand what's the deal with that. But I just don't know what to do about that, This is the thing that was just taking for 120 milliseconds before and after my change. Where realistically it should have, I mean, it should really be taking a bit. We should be able to see a noticeable difference, would be my guess. but we don't. I don't know. I don't know. I think it's going to be a good place to stop though coming up pretty soon, because I got done the main thing that I wanted to do. I finished changing execgen.range to just get rid of it altogether to improve the simplicity of all this stuff. I added a bunch of bounds check eliminations. Some stuff got a little bit confused, but I think the overall goal was accomplished. So thanks everyone for tuning in. I think we're gonna try to find a raid. I think if my friend Jason is still streaming, I want to raid him because I told him I would. But if you did enjoy this, by the way, so I stream every Friday at 3 p.m. EST and most Sundays in the afternoon. So do give me a follow if you haven't already. You'll get a notification when I stream, and you can come hang out again. You should follow me on Twitter as well. I announce when I stream on Twitter, and so we can stay in touch that way. And it does really help me out to give me that follow, so I would appreciate it. But anyway, let's go check out if Jason is streaming and give him a raid if he is. So cool. We're gonna, yeah, let's go ahead and raid him. So raid. So yeah, go say hi to Jason. He's doing something probably pretty nifty. Say hello, give him my best. And otherwise, I will see you guys next time. So have a great rest of your evening. Enjoy. And that's about